Should I start? Okay, good morning everyone. We will continue with lecture 4. If I remember well, we finish until slide 20. So I will just go to this slide. I already described what is dominant spectral component. That is the strongest reflection. Good morning. That is strongest reflection in our Doppler spectra caused by end of the end tips of the blades, and we just finished on these slides yesterday, so I will continue and finish lecture 4. It is about next 20-25 slides, something like this, and we continue lecture 5. So there is example how Doppler spectrum is affected by signal from reflected from wind turbines. There is just example. I will describe original spectrum that should be visible in our radar. Unfortunately, due to PRF, our zone is in range plus minus 500 Hz. So it is in this range. So we are outside this range. So what's happened? Of course, it is happen aliasing of signal. This is presentation of replica of this spectra. Because you know this is original spectrum. This will be -1 replica, -2, -3, -4, and so on. And there will be original 1, 2, 3, 4, and so on, because spectrum is periodically repeated due to this aliasing. So what's happened? How will looks our signal? Imagine that our reflection has central frequency after sampling about 750 Hz, but due to this aliasing, it is described by this formula, and it is sum of individual repetition periods, and they are of course infinity, because it is original, first zone, second, third, 4, 5, 6, 7, and so on, and it is for positive, and also it is for negative. So due to this aliasing, due to this limitation of our range plus minus 500 Hz, our reflection not will be visible in this frequency, but aliasing frequency will be right frequency. It is this 750 minus round f through divided PRF again, and if you will compute, it is my 250 Hz. So what's happened? We won't mitigate this one, but unfortunately due to low PRF, and you can't choose it always, because what depends Doppler frequency, maximum Doppler frequency of this spectra? On rotation speed, length of blade, and so on. So you can influence this thing, because it is depend also on speed of wind, rotation speed, and so on and so on. So this spectrum will be in minus 250 Hz, and it causes us problem. Why? Due to this aliasing, of course, our mitigated algorithm, that is derived from UKF filtration, it is Kalman filter, try to estimate where will be in next step this maximum. So he will expect something like this, around this, but due to aliasing, it will be there. So of course, due to this aliasing, when aliasing occurs, our estimation algorithm, prediction algorithm fail. Of course, if will be only in one spectra or 2, 3 of them, 2, 3 prediction, it will be okay. The prediction algorithm can handle it. But if will be continuously for longer time, then this prediction fail, and what's happen? Mitigation algorithm will stop work. But you can handle with this, because it is, how to say, it is not your fault. It is not fault of mitigation algorithm. This works fine, but due to this aliasing, this sometimes could happen. But when happens, it not will be so often. Only when this Doppler frequency will be very high, and it is mean for really high speed of rotation with length blade or something. But could happen. Just you need be how to say, you need be careful about this. Okay, so now I will talk a little about high variability of wind turbine RCS. I already told you what is RCS. It is radar cross section, it is radar signature, and it is measure like object visibility strength of reflection. It is on meter square, and the definition formula is sigma is limitation r go to infinity 4p r square capital SS divided SE. And what is it? You can see why, sorry, where is my mouse there, that y is meter square, because this divided, this has say units, so it will be of course meter square, and SS is scattered power density and SE in incident power density. And what is mean? You have some energy that go from your antenna beam to target, and it is this amount of energy that hit target. And what is SS? It is reflected energy. So it is basically like two energies, but of course you will hit target, but in some area. So reason is why it is in meter square and Vp r squared. So on which, what is dependency of RCS? Okay, there also I won't present, I found already from this source example of wind turbines reflection. It is in one time instance, so it is mean it is in one time. In second time will be completely different. If you change some angles, anything, rotation speed, it will change, of course, this diagram. And check, it looks pretty complicated, isn't it? It is hard to make decision. There is not any, how it is look like almost random. Why? Because every part of surface have another reflection angle, and the result is this. So I even can't describe more. It is just results. It will look something like this, and it, of course, and if you will change about 1 degree angle of blades, it will looks completely another shape, another shape, another. So this, you must say, you can't predict. It is not possible. This frequency, this measurement was made on frequency 3 GHz with horizontal polarization. It was wind turbine from company Enercon E70, and rotor diameter was 70 meter and tower height 65 meters. So relatively small wind turbines, but it is nice example how looks real RCS from wind turbine. If you don't know that is from wind turbine, and I told you that is from some UAV or from some plane, you can't recognize because everything looks similar. It is something like this. So you can see that reflection is very variable and vary in the units are in dB. So you can see that this is really big differences. And why in some angles is almost zero and in some angles is maximum. It is depends how it's reflected, how looks surface, how is rotated, which angle, because in some angles energy can reflect to space and you don't know it. And of course it is depends on movement and so on and so on. So it is not possible to predict. So dependency of wind turbine RCS is on rotation of the wind turbine nacelle. Of course it is how it's rotated. Blade hub, or it is orientation, generally orientation of wind turbines, rotation speed of the blades, and it is depends on wind. So generally you can't predict this also. And on also depends on polarization and frequency of the signal transmitted to PRS. So it is carrier frequency, okay, we can change it, it is based on our radar parameters. And polarization, okay, it could be horizontal, vertical or cross polarization, and it is mean you transfer one like polarization but receiving another polarization, so it is just cross polarization. It is this reason. Also depends very much on specific type of wind turbines, because shape of blade is in each turbine little similar, of course, but different, for sure, little different. And also it is depends, and I missed there, on material, because individual material, they have different reflections, so also on this. So it is so many variable, how you can see that these are. What is typical RCS of wind turbine? It is very, how to say, very variable, and it is from 100, oh sorry, there is Czech word, up to 1000 meters square in dB, about 20 to 30 dBsm. And this value for sure mask almost any of your target. And if you will take care about small target, it will mask for 100%, because the reflection RCS of these targets will be on similar level or low level. So if you will look at the same direction where is this strong, you don't have any chance to saw it this target. Another approach how get RCS is in FEM RCS simulation, but we don't include it. It is very hard and very hard. It is very computational intense, very, because of course we can simulate one shape blade. It is available, this shape of blades in 3D CAD, so it is not problem to get it. But imagine it is depend on frequency, it is wavelength. So I need to take this model and make this model like 150 meters length. In 3D I know that is possible, it is not problem, it is just ratio. But then you need to compute the reflection surface on this every small units to get RCS. How you could measure RCS generally? You know probably that is in anechoic chamber. So we have some experience also with measurement of RCS of UAV, because we have anechoic chamber 5 by 5 by 5 meters, something like this. So we can measure some smaller object, but for UAV it's not problem. I think that maximum what we already measure, it was UAV with wings, and it was about 1.5–2 meters, something like this, because for bigger objects you need to be in far zone, not in close zone. So of course for us it's not possible to measure this one. Why you can't measure directly RCS outside? Because it is influenced by environment, other signal that is in environment and so on. So you will not get the okay, you will get measurement, but you don't, it is not mean that it is RCS, just RCS. It is RCS plus much more other reflection. Now we leave for few slides, formulas and all this, and we go, I hope, to little interesting thing. It is about analysis. This is example of scenario. Until now it was like purely theoretical, if I can say. We just think invent. Modeling, simulation, calculation are but not enough. Imagine that I need make some measurement. Okay, I can look at map, Google Map, our maps.com and so on, and check it. Okay, it is good place for measurement, I will go there, and so on and so on. But it is map. It is not exactly right. So you always need go to Street View or something like this and check it. Did I select proper measurement? because imagine you will select some displays and now you figure out that there is wood and you can saw it. So good preparation of your scenario based on publicly available maps and or another types of software that I will later show you. It will help you save your time, that you will arrive to measurement place and figure out that is not good place. So for measurement, real wind turbine is also embedded in specific geography, so you can get information also about trees, about roads. Imagine that you plan like on opposite side of road, on like left side, that you want make measurement from this distance if you will continue, and now you figure out that there is main road and just driving cars. And what this mean? That is rotation of the wheel. It is small wind turbine. It is rotation. It is again will be RCS, and you don't get valid measurements. So site selection, it is very important, and honestly we spend a lot of hours before we go outside to take proper minimally 2-3 places where we can get measurement. Why more places than one? Because we don't know in exact day, exact hour, how will be rotated wind turbine. It is also for you unknown. So it is better planned 2, 3, 4 measurement. And now you need to fulfill, of course, ambiguity range, blind zone range, and power range, power budget, and all these things. So you found good place, and then you figure out, oh, it is too far, I don't have enough power. Okay, and you search it again and again. So this planning looks like that is not important. It is very important because save your time. Save your time. Also, probably 2 or 3 times happened that we just arrive, we check 1 day before, okay, turbine's working, we driving 70 kilometers, and there was some maintenance and we just go back. So it is not so easy task. So please, if you will handle it with these things, plan carefully and from publicly available sources. Of course, everybody knows Google Map. They are good, but they don't have it measurement of distance and elevation profile. For this reason, I little force you. It is Czech site, mappy.com. It was mappy CZ, but they changed it before few months to be globally, and of course it is also in English, so don't worry, it is not only in Czech, but there is measurement distance, and when you just put 1 point, second point, it always will show you elevation profile. Of course, elevation profile, it is just approximation. There is no woods, there is no trees, there is no buildings, and so on. So need be careful about this. Also, measurement very strongly depends on windy season, daytime, and also on acquisition period. So there is an example from one of our measurement. Don't worry, I will have more example and you will try it. It is really crucial use map-based tools. It is not from Google Maps, but from our side, and you can see where is red one. It is mean where is possible like street view that you can rotate in and check it like classic street view. They call it panorama, I think, but it is the same things. So this is, I don't know if you see this triangle. It is the view where I watch it, and it is just copy and paste photograph. So you can see 2 wind turbines. Good visibility, there is some field, there is no tree, okay. We can go for measurement. And always plan like this. It is not so hard, okay, understand, take some time, but it is not so hard and really save your time. So problem is that we plan few times some better place, because this is of course roads, small roads and so on, but then figure out that there is some tree, there is some, I don't know, pond with reflection, there is something what is not good for measurement. So for this reason you always need to check carefully, and this help you, for sure this help you, because there you can have some obstacles, there can be even some new, how to say, buildings, barns, if you are in agriculture, anything, and this is problem. Also, always first check what is version of your map sources, because sometimes you can switch to newest one. Probably it is always newest one, first choice, but check it, because it will be 2-3 years old. Like on Google Maps, some area is older, some are newer, because they are updating, but not whole world, of course, regularly. Check it, because it is also just very important things. Oh, 3-4 years old, you cannot believe it, especially if you will be close to some density area where is a lot of buildings, because they are growing very quickly, you know it, so this could be also problem. And other clutter, but I already mentioned, is unresolvable highway traffic, and this really costs you problem. This rotating wheel, it is perfect reflection. You can't recognize. Okay, imagine if you have rotating wheel on car, you have 2 of them, of course, you can see it from side. It is like rotation of blades. In UAV or something like this, it is completely same RCS characteristic, or it will be micro Doppler, it will be completely same. So you can't recognize this one. It is similar, how to say, it is similar movement. Why I explain this highway traffic, because we already found very good, nice place for measurement, and we figured out that it was so high traffic that we can do it. So it is from own experience. Okay, there is some other example analysis. We always prepare scenario where we won't make measurement. When we decide where will be good place for measurement, like this one, position of, I call it radar, but of course it is our measurement chain, but it could be radar. This is individual small villages, this is main road, and this is city Litomyšl. It is about 40 kilometers far away from our city Pardubice. And you can see this is line of sight. There is position of wind turbines, and there is, if you could make, how to say, zoom, there is 1 and 2nd wind turbine. Later I will show you exactly in data. So I want to highlight that your measurement and everything is also related on quality of our geographic data, because map, this map, any map, it is not picture. It is list of geo objects, and it is important to inform. Of course, for us, Lukács picture where we won't go through navigation, I don't know, but it is not true. Any object, if you will zoom it, you will see individual buildings, and everything is object. And like like example, OpenStreetMaps allow you check which type of object, and sometimes give you information about, I will show you there in OpenStreetMap, that there will be information about which type of wind turbine, which hub size, who is developed this, where is exact location with 1 meter, and so on and so on. So save your time with map. You will spend 1-2 hours with map, and you will save a lot of hours with going there, gathering equipment, and so on. So be careful, map is not picture. even it looks like picture, it is not. There, where you can get good data source, I recommend free source OpenStreetMap. If of course you have some commercial like commercial maps, or I don't know, you are working in partial military, so if you have military map it will be much better, because there will be any object even with a lot of additional parameters about height of building and so on and so on. It is always depends on details. But OpenStreetMaps, I like it because they show you a lot of information, and there is example from OpenStreetMap. If you will click information, where is it, what is it about this object, so I click to my wind turbine, of course, so you can see it is generator method, it's wind turbine 2 megawatts, it is wind turbine, of course it is like source of energy, it is different categories, and everything it is like subcategories of geo objects. So you can see it is not picture, it is really objects. And what is really nice on this, on OpenStreetMap, that you can make like filtering which object you are interested, which not you are interested. You can even download it from specific area, this object, and put to your some GIS system, map system, and this allow you working offline or with all object that you are interested only. So you want only wind turbine, okay, just download information about wind turbine. You want interested in buildings, okay, download buildings, and so on and so on. So it is really nice and powerful tool. I don't know if you have experience with this one, because everybody looks like, okay, it is map. It is not, it is true, but it is not only map. And it is really easy. You can see there is manufacture, wick of wind. It is model wind turbine, and if from model wind turbine I can find data sheet, I can find anything. What is blade length, what is rotor, what is tower length, what is power, what is maximal speed of rotation, minimal, oh, okay, minimal will be static, so it will be 0, but you get my point. It is very useful, and you can just sit on your PC and you will get all this information without any reason go to displays before measurement. And something else, yes, there is also source of information. And now one important thing, I choose this one because there is a lot of information, but of course in a lot of sites there is no information, then you need to go there and check it. So it is not like 100% sure, but always check it, always check it. I check a lot of wind turbines in Tamil Nadu, where is this big area, and unfortunately there is no information about this wind turbine, so I don't know which type of wind turbine. I try use Street View close to this wind turbines where was available. Unfortunately, around this small street there is so many buildings that I don't found any like view to these wind turbines, or maybe some part of blade or something. So sometimes it's possible, sometimes it's not. It is depends, of course. But I didn't expect that, especially in Tamil Nadu, will be information about all of them, because I think it is thousands of them. But you can find it also maybe on internet somewhere else. But please use this. And now I will. You probably know OpenStreetMap. So I will open this one. I hope that connection works. Yes, works. Okay, so I will zoom you. So check. There is Pardubice, where is now university, and there is main road which go to Moravia, it is this part Litomyšl that I show you on map, and they call it Vinturbai Janov because it is this smaller village, it is closest one. And if you can just go down, okay, sorry, there is, oh, you saw it, I don't saw it in this screen, so it is there. If you, of course, please, I will switch to English. It is always, my system is in Czech, of course, operation, so it show me in my system. You can check it, and if you will click this, you can see this exclamation. You can click read futures, and there is VTA. It is wind turbine, but in Czech you open and you can see all this information. If I will go there, it is in Czech, so it is Czech side, but you can make a Google translation, and now you have power, tower height, rotor, so the wall weight, total weight with blade 100, and so on and so on. So you can see I can find a lot of information on web. There is some additional information. Oh, it is what I already showed you, sorry. And one more software that will be very, very important for you is this one. It is QGIS software. It is visualization of any map layer that you can imagine. It includes thousand and thousand plugins for different viewing, for handling with maps, and each map, like you download map from how to say, from OpenStreetMap, then you will download layer about wind turbine, then you can with building and so on, and you can work with this like with layers only. And what is the best? It is free. It is community project for 25 years. It is size 1.2 giga, something like this. You can download it, and map sources you can put on. You can download CRTM data. You can download digital elevation profiles data. You can download information about building, wind turbines, what you want. OpenStreetMap, and everything will be like one layer. We are using this software often, but honestly I think that I will use this software from point of view the whole functionality maybe for 0.1%, because it is huge, so huge for many tasks that I just use for wind turbines and for these few things. So I will show you later some example how it looks like. So I recommend you this one, and it is free. It is perfect. It is also free. So I already talked about digital elevation model. So why is for me important? Visibility, line of sight. You can see. Of course, you can check it through this panorama or street view, but never can be sure that is right. Or how to say, it is good source, but sometimes you need to compute directly line of sight. Sometimes you need to work even with reflection from environment. So I will later show you how you can get 3D elevation model. It is imported to MATLAB of any part of world. It is freely available. It is they call it CRTM data. It is space shuttle mission with SAR, radar. It is on board. Resolution is free, and it is approximately about 90 meters and 30 meters. And the whole world except Arctica, Antarctica, I think, except these two areas, it is with resolution 30 meters. And it is on tiles. It is like one tile, second tile. So you will download only area that you need. Import to MATLAB. I also share this tool it is available on MATLAB Central, and you just downloaded this tile, put it to MATLAB, and then you can make presentation. By the way, this one, it is position of my radar, and this is position of wind turbine, but it is not in good ratio. It is just for, how to say, for example, if you get my point, where is it? Because of course radar is not so high, it will be down, and this is too low. It is just picturing where is your position. You can make rotation, you can make computation, you can do anything. I know there is no information about woods, about any obstacles, but still really nice one. Because if you will picture this one from 2D, you will see something like this. Okay, perfect. Again, this is not in a good ratio, it is just picturing. But this is digital elevation model, and it is perfect because you can see easily. Is there good visibility or not? Imagine I will be there. Okay, there is no visibility, or there will be some hill, and you have Himalaya, something like this. There is really like not flat. So it is good tool. It is good tool, and I recommend you. And it is even a little fun work with this. It is interesting. This tail, if you download, if your like area is through more tails, you need to manually connect it each other. Why manually? Because you need to tell this is first, second, third, fourth, five, and second layer, and so on. But it is not so bad. You will download it very easily and then just connect together, and you can see this one. Again, during tutorial you play with this, and I will give you all this MATLAB file so you can play it. Only I have downloaded data about Czech Republic, the whole Czech Republic, because we are a small country, and I will show you also how you can download any part that you want. So, but we made analysis in Czech, so everything looking at Czech, but it is not important, it is just another type of data. So, and what is good thing, I can in QGIS, in this, where was? No. In QGIS, oh, there, in QGIS software, I can easily this digital elevation model put to QGIS, so you will see map like this one, you will see elevation profile, you will see wind turbines, and everything. You could like make more intensive, less intensive. What do you want to see? You can disable individual layer, enable individual layer. So what you want, you can just make visualization. So it is really powerful tool and free. I think that is really nice. There is one thing about, it is German words. I don't speak German, I will try. Dunkelflaute, something like this, and it is special words. And it is German term for combining dark and calm. What is mean? When is no wind, it is referring to periods with low wind and low solar irradiance, and this is example of activity. There is how many megawatts in some area was like, how to say, made it from wind turbines. So you can see this is intensive, there probably no wind, intensive, and so on. And this area is almost close to zero. What does mean? Dark and no wind, completely no wind, really calm down weather. And what does mean? All wind turbines in this area will stop work. And why I take care about it? Because when they stop, they are not moving, and if they are not moving, no Doppler shift, and if no Doppler shift, for me is static object, MTI filter is enough. So it is just interesting thing, and it is really, you need to be careful if there is some prediction that this period will happen, don't go to measure, because it will be just static object. So I want also show that this how to say interferences of RTS, which depends on speed, is really strongly weather dependent, and this is just presentation of this. So measurement timing, you need to go with windy season, daytime, and you with some data acquisition period. And of course, in any country, in any area will be different, this one, so you need to plan carefully. There is one interesting paper that we found during our research, and it is about exactly this Dunkelflaute period analysis in China. There is lot of graph and some statistic. So you can see when during January, February, March, April, there is number of days when was sun, when is dark, when is wind, where is no wind, and so on and so on. So also you you can check this different statistic if it's available maybe for India, for any country, because it will help you also with planning when go to measure. So it is this environmental layer is very important, because also it's connect your modeling and prediction with real work operational variability. Because imagine you can also make some adoption of your mitigation technique depends on this, because you know that with some statistic in this time is some kind of behavior. In other time during nights it is another behavior, but it is good for adoption of your mitigation algorithm. Of course it is very detailed, I agree, you don't need to use it, but you can, and if you will use it, it is just next layer of your model, and it will be deeper and deeper and precisely and precise and better and better and better with better results. So combining basic metadata with your model, it also could help. It is just next layer of information, and you know it is always, if you have more information, results are better, always. It is same like AD conversion. If I will gather more samples, I have more information. And this is honestly, I think, the most important metadata. You need all possible information about your modeling, log files or measurement, and it is metadata. How you have set your SDR devices, how you have set PRI, PRF, which type of modulation, what was length of pulse, what was distance of measurement, and so on and so on and so on. Everything must be recorded, because if you don't do it, I can bet with you that after 1 month you open raw data measurement and you don't know anything under which condition you make measurement, and then you can just delete the data and go again, because it is not possible to get this information from this. So be careful about this. I know something about it, because during our start of measurement sometimes we forget something and we need to modulate again, because of course we also sometimes you forgot something to save. So all measured data must have subsequent valid interpretation. You need to know condition. And about measurement, there is one thing. You never know speed of rotation. Do you agree? Because you just came to size, start of measurement, and you don't know how quickly rotate it. Always make video recording, because from video record you can easily detect one rotation. From one rotation you get lot of information, speed, type of wind turbines you already know it, so you can put every information to your model And then measurement and your model results, you will make comparison and it will be almost same. And what is advantage? You know setting of model, and now I can change just angle, initial angle, rotation of speed, and even if I don't have measurement for this different setting, I know that is valid because the setting was already one time set and confirmed. And this is really important. So also what you need to record, equipment. So in our case it was some antennas, okay, they are passive, so it was about amplifier. What was amplification of signal? Also, what was some noise number setting? What was everything? Record everything. Maybe it is look that is annoying and that you don't need it. Okay, you don't need it now, but you don't know if you don't need it after 1 month, and if you don't have it, you don't have it. So also type of equipment, serial number, status, configuration, because what could be configuration? Sampling rate, something like this. If you don't have good sampling rate, okay, how you want to interpret data. Records of pre-measurement analysis, sensor position, of course, XYZ coordinates, weather, also information about weather, because weather influence reflections. So please also make just information. Sunny day, wind speed approximately 5 up to 10 meters per second. There was snow fog, I don't know, it is just example. Just make small record. It take you 1 minute, but save your time for later. Because imagine if we go for measurement, it will be snowing. Also, it will be completely different results, or with sunny day. And it could happen that you will then designing mitigation algorithms, and you will be back on your data after 2 years. You don't know nothing about this, where it was. So photography, video, everything. It is enough. We always make with mobile. It is enough. You don't need high quality. Just make all these records. Of course, time of records, video. So it is rotor tuning rate and orientation. Yes, it is clear. I forgot, it is true. Orientation, of course. You can derive angle because you know it. You need it to angle for your simulation. I almost forgot. And in case that there will be some small roads or something, all roads, traffic. It was a lot of traffic. Okay, there is influence of this measurement, specific measurement by traffic. No traffic, okay, perfect. It is better believe more in these results where is no traffic. So proper metadata make it possible to reproduce experiments by your simulator designed. So it very help you. You can also compare scenarios. Okay, we make measurement and 3 kilometers and 5 in same of line of sight. What is differences? But if you don't have information that was in 3 and 5 kilometers, for you is just data without any meaning. Also, if you will later model a lot of data, you can use it like 1,000 and 1,000 scenarios. You can make some automation script that you will run it one time, and he will take like individual scenarios, always compute for each scenario one reflected signal and continue with another, and it could be 1,000 of them. And then you can use it for ML AI algorithms for training data set. But first, of course, you need to have validate that model is correct. Of course, it is true. But yes, it is like this. So metadata, big importance, because people very often forget about this. And I understand, because you go, I remember that was rainy. Yes, now, after 4 days, 5 days, 2 weeks vacation, no, you don't remember. Especially if in one day you make, like example, 10, 15, 20 measurement. No, you don't remember. Even, okay, it will be 20 measurement, I will not remember even during night, same day, because it is hard. So be careful about this. And it does not take so much time, honestly. There is example of acquisition planning. The goal was to design a campaign that yields to maximally information data for model validation and algorithm testing. So, of course, first we developed model, but we was not sure that was precise. It was just our idea. So then we design measurement chain. We working on this parallelly, of course, and we design new antennas, and there is some typical scenario. So it is control PC, antennas, SDR is below. I will show you more picture later, so don't worry. Now somebody of you can complain, yeah, but it is antenna that is static. True, we don't use rotation. Why? We don't need, because it will be more complicated for us. So we make recording from 6 up to 18 seconds due to data rate limitation. Not in our hard drive, it was enough space, but problem is with SDR. If you have bandwidth 40 megahertz, there is some cache memory, and after some time this cache memory start overflowing, so we need to adjust. So back to your question, we just adjusting this 40 megahertz that was related to cache memory of our SDR, because if we will put 50, 60 megahertz, because we want also more, SDR can't handle it with this high data rate, and always after few seconds of record cause it problem, overflowing and shut down. So I remember now it was about this SDR cache memory. But it depends on your devices. If you have better devices or real radar, it will be something else, of course. But we make this measurement. So our measurement, radar antenna position, we make record of coordinates. Height, it was about 450 meters high. Transmission frequency was about 3 gigahertz. Same like we use it during tutorial 1. Radar antenna rotation time, we usually agree about 10 seconds, but for measurement it is not valid, of course, because it was like continuous pulse signal that we send it to wind turbines. And it looks like big one, but main lobe was really narrow. So even we could separate each wind turbine. If you can understand me, we focus only on 1 or 2 second one. We don't make record of both of this wind turbine together. And it was possible due to this really narrow main lobe of antenna. So we precisely know where we are aiming. The repetition period was about half millisecond, and RF pulse was not modulated, so we don't use any pulse compression. But it is just for validation of measurement. We don't use compression even in our simulator, so we don't use compression even in our measurement SDR. But we can set it compression that we want, but we don't use it because we don't need it. We just want to make comparison. Of course, if we will use compression, then we need to use compression on measurement side and in also in, how to say, in simulation side, and then again we get valid comparison if it's valid or not. So there is position of wind turbines. I placed this data because later you can play with it and you can just shown on map. Tower height was 80 meters, rotor diameter 80 meters. So it was like testing measurement. uh, there is example, if because you know that our simulator handle with each blade like with tube that is slice it to individual element, but you can easily download model of wind turbine and it is free. This is a GrabCAD. It is free software. Again, you don't need spend any money for this, and you can download. It is just example. When I put to database in GrabCAD, that is free because it is from like community, from users. I found it maybe 100 different type of models of blades, the wall wind turbines, towers, and so on and so on. So this you can use it for your FEM simulation if you want in CST Studio or something like this. I don't know, do you know CST Studio?
Yes.
Yes. I thinking because almost everybody use it. Who do it microwave or something?
GIAN simulations in like for antenna metamaterial.
Yeah, exactly. So you know it. So you can easily download these models and just directly import. And not only wind turbine, it is thousands. So if you need, there is a lot of antennas also, different types that are adjustable. All parameters are adjustable, so you can even make changes in this model. So I recommend to it, and it is also free, so why not?
This one also simulation software.
Yeah, it is it is simulation. So of course, it's not so good like CST, but CST prices. It is licensed. I know. We have it also, because my colleague from microwave group, they use it also. But this is, you can check it. It is not bad software, and it is easy. So in this software, of course, you can control wind speed because it's like some rotation, orientation, reflectivity of surface elements, everything. But probably your colleague will tell you more information than me because I am not FEM specialist. I don't working with this. It is microwave things. And now I will go to last 7 slides will be related how different parameter of wind turbines influence your reflected signal. It is outputs from our simulator. Just make it give to. You can see that this is analysis of wind turbine nacelle orientation with respect to radar. So it is mean how, if is this blades, how is rotated to my radar. So you can see that there is high variability. Okay, 0. What do you mean? If you see just this line, what is it? The red line. Now, it is just reflection from tower. It is mean that your wind turbine is just directly in this way. Why? Because its rotation and distance is still same, so there is no Doppler shift. When is maximum? Okay, there was maximum. It is like this one, maximum Doppler shift. So you can see that, and check this one. It is like rotation of wind with respect to your, and y is not in 0. Wait. Now, y is in 330 or in 150. Because azimuth was not in 0, but is one bit, it was in 30 degrees. So you can see now nice example of our simulator, of our output. It is spectrogram. There is Doppler shift. So you can see that if there is radar and I go with blades like this, it is increasing Doppler shift. It is clear because it is more speed with respect to my radar. If it's this, it is zero Doppler shift and it is just tower, static object. And how you can recognize that it's static? Zero Doppler shift. Zero Doppler shift is static reflection from environment something. And everywhere where is blue, it is like zero. There is no reflection. But in real measurement, there not will be anything blue. Why? Environment. Of course, it will be messy. And you can also see these three harmonic signals. I know it is later I will have this picture, but no animation, so we can just check it later. So it is three harmonic signal. But please don't expect that in a real measurement, where is influence environment, you will see so nice three harmonic signals. You need to have big imagination, but it is work. Results are almost same, but you need imagination. Where is it? Because of course this is simulation. There is no environment. Reflectivity is unit, but RCS is not unit. It will be changing, of course. But we. So I will check if I forget something. No, I think that not. Okay, it is what I already present, but not in GIF. So you can check that in this. Okay, in this case, okay, it is 0, 30. Okay, it is maximum. Now it is like this. You can see tower, and if I will go, it is 30. It is okay. 0, 30, 60, 90, 120, 150, 180. So it is mean what? That I am looking like this, rotating, and then I am in opposite. So it is same like if I will go around with radar position. I just rotating with wind turbine. But what is disadvantages? I will take one measurement for one angle. I will validate that is with good setting of my simulator. I confirm result that is very similar or same. And then rest I simulate from my chair in my office. I don't need go to again to make measurement. And in second thing, the condition will be never same, so another measurement. But now I can simulate. Even I have step 30 degree. You need more detail? Okay, just put more detail. All these input parameters like number of blades, angle, rotation, and so on, we save it in just Excel file, and you just put values that you want, and our simulator just read values from Excel and simulate and save result. So it is it is very big automation. So you will put just, you could put hundreds of simulator in a row, just press it, run, and come after a few hours, and everything will be simulated, and you don't need to spend so much time. Check this, and this result are same. Do you agree? Why? Because it is like this, and if I will rotate 180 degree, it is like this. Of course, it is the same. What is difference is, it is rotating like this or like this. It is just different area. And check this point and this point. It is like mirroring only. It is like mirroring. But of course, if we use same inputs data and just change angle, it must be same, just rotation. So if you want save time, you need from 0 to 180, and you don't need this one. If you want this one, just make mirroring in MATLAB because it is just metric, so, and it is done. Sorry? 5 slides, 10 minutes. Please,
Okay.
please, please. I will finish and then we will go for lecture 5. Please, please.
Yeah.
It will be quick because almost everything I already say. So, this is Doppler spectral component are caused by radial velocity. We know it. Non-zero component are artifacts caused by Doppler shift. But there is no Doppler shift, so it is mean that we are exactly in the way where it's only tower. Tower not caused our problem because it is MTI filtration. There is maximum Doppler shift, so it is mean that your blades are just in exactly position and there is biggest movement, and this radial velocity components of the tip velocity is done by this formula. It is speed of tip, and this is this individual angles, and maximum Doppler shift is derived from rotation speed, and it is some minus Fd max to Fd max. So radial span of velocities and consequently Doppler shift is orientation dependent, but it is clear we already saw it from result. And okay, it is just results what we say, and there I will show you next simulation, and it is changing of rotation speed, how it looks. So my rotation speed is 1 RPM, 4, 7, 10, 13, 15. You can put any value. What is maximum speed of the blade tips? Meter per second, 4, 17, 50, up to 55, and so on. And I today add that was for PRI 1 millisecond and blade length only 40 meters. It is just for example. Of course, you can put any value. And this is bandwidth of Doppler spectrum that is expected from minus 350 to 50, and so on and so on and so on. So, what was result? Check. What is happened? If will be higher rotation speed, the amplitude will be higher and higher and higher and higher and higher, and then go outside my range. You check it, and it is this picture. So there is detail. There is one sine wave which continue. There is second wave, but looks continue there. Okay, second side. It is go there, sine wave. But this part you can't see aliasing. How I already told you, aliasing. It is reflected to second side, and you have problem. Houston, we have problem because there our mitigation algorithm don't expect this one because he expect free sine wave. But due to aliasing, we are in opposite side. And there you have details. So low rotation speed, almost not any Doppler. So with low rotation, you can behave like static object. Higher, 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 it is almost maximum, how you can see. And if I will make bigger rotation, aliasing, and it is bad for our mitigation algorithm. Last slide, tea break. So thank you for attention, and we will continue after tea break with lecture 5. Please, there will be a lot of formulas because it will be mathematical description of the whole algorithm. I will show you how to be complicated formulas. But then will be lecture 6, it is measurement chain, it is more fun, and 7, it is mitigation algorithm, and it will be also a lot of picture and videos. So lecture 5 will be little hard with formulas, but and you will have my script later. is planned lunch 12:30 or 1:30? 1:30. Because I need to squeeze this 5 lecture to exactly timing. I still have problem with this. Yeah, 1:30. It is good. It is nice. No, 12:30. Oh, 45 minutes. Okay, no chance. But tomorrow we will. So we will wait for other people and we'll start. Or we can start. You think? Oh, maybe wait a few minutes.
In previous slides you share capture the data. We use like 30 degrees. But in reality, the direction of wind will not suddenly change. Like we need to wait for like months of time to collect all the data. Like 30
Yeah, but you can collect only one data from one position, and you know why? Because you need this data just for validation of your simulation, but we already validate on our data. So now you can just plan if you won't get reflection from some wind turbine in, like example, Tamil Nadu. Just put position of radar, put position of Tamil Nadu wind turbine, rotation speed that you want, and simulate. You don't need to go to measurement because it is model is already validated that fit, and it will fit for any scenario.
Means you just have to calibrate the right data into the simulation.
Yeah, by the way, we do it this calibration data to simulation just for validation of our model.
So you will get the right output no matter where you are. Just
Exactly, just use model. Now you can use model worldwide where you want. Exactly. But because, you know, we plan a model, but without validation, we can't be sure that we are right. So for this reason, we design a measurement chain, make measurement, and try to tighten if it's good or not similarity. And similarity was good, and we validate for about 20-25 data set, different wind turbines and so on, under different condition. So now I am pretty sure that will work under any condition. So you don't need go for measurement.
Basically, you are saying we have a standard model of any type of turbine, and on the basis of that we can calculate the parameters.
Yeah, you will saw it tomorrow when we make like lecture and tutorial on this simulator. You will just open Excel file and put length of tower 120, length of blade 120, I don't know. You put just input parameters and click to simulate, and it is done. So now you don't need it go for measure. Of course, if you want to be sure, you will go for validation, but generally you don't need. So there is no necessity, but for us was necessary because we need to validate that our model is good. Without this, it is just some equation, and you can believe, you can't believe.
That is the thing that I was thinking.
Yeah. No, you don't need to go there. But still, if will be in real scenario for some real radar, probably you will make a lot of simulations, And you know, this is not only about reflection. Reflection is one thing, okay, you will compute, simulate reflection, it is important, but what is most important, you will use this data for design of mitigation. Without data, you can't design. And you can't design mitigation algorithm only based on measurement. Why? Because you will have 2-3 measurements from 2-3 data set. It is too low, you can't do it. You need all scenario, all rotation speed, everything. Because then if you will do it just based on measurement, what's happened? Okay, you design mitigation algorithm that will work for this blade length, for this rotation speed. But if it will change for this angle, but then will stop work. But now I can simulate anything and just put any scenario to my mitigation algorithm and check. Works, didn't work, I need to change it. So like this, it is just for this reason. Okay, we will start. We will not wait for other people, if never mind. Yeah. So, this lecture will be about mathematical description of the model or simulator. I don't know which word you want to use. It is model or simulator. From my point of view, it is almost same. So, the model is macroscopic modeling of the reflectivity, motion and geometry of wind turbines. You already saw it yesterday. Model outcome is not spectrum or spectrogram, but model outcome is received signal, reflected signal. But of course, visualization is based on spectrum and spectrogram, but output is just signals, IQ data. Why? Because I can make anything with IQ data, but if output will only spectrum, okay, I can visualize, but it is all. But I need raw data. For me, it's like raw data of this one. So it is reason why we do it. What is advantage that you can simulate any output, any input parameter that I already mentioned, and that you can also make like lower or higher resolution. What is resolution? Length of blade element. It is variable. I can change it. Of course, it will be very short. Computation take longer time, but never mind. So it is made advantages. So the presented model was compared with signal with real measurement. Not with signal, because if I will compare one signal and simulated signal, it will be different, of course. But we make comparison of spectra and spectrograms. And you will see later that fit very nicely. Of course, lot of differences caused by reflection of environment, of real materials, of real RCS. But the DSC, this component is still visible, flash are still visible, tower is still visible, so fidelity is relatively nice. Model was developed in a MATLAB environment. Of course, it could be rewritten to any other software because it is just script language. So if you want to speed up and make real application, use C, C++, Python, what do you want? Because it is how you will see now, it is just mathematical equations, so why not? You can just convert it. And in present time with ChatGPT or something, it is very easy, just put him and expect in another language, so it is no issue. We focus on single wind turbines modeling. I already told you, not all multiple or wind farms. Why? Because what is wind farm? It is just more wind turbines together. So it is summation of together. So if I will design one, what is difference if I design two and make sum of both signals? It is same. It is superposition. And in case of more wind turbines, we have also problem with fact That will be superposition of influence of both or three. It will be hard to make decision what is influencing which parameter influencing each other. But if I will do it solitarily and works, for second works, okay. If I will see some of wind turbines, it will work also. Of course, the validation is crucial, but it is clear because without validation you have model and you can't be sure if it's true or not. So, reason why we developing model, I already mentioned some of them, so I will maybe some of them skip it. Real radar data containing wind turbines reflection are in the majority of cases not available. But if radar not focus on wind turbine reflections, because we checking areas, there is reflection of everything, every clutter, targets. How you want to separate just wind turbines data? It is not possible because it is superposition of all reflections. But you need to have only measure data of wind turbines and of course surrounded environment because you can't remove it. But imagine if I have wind turbine and there will be blades, I always can measure like this one. So focus only on moving blades, not going like this one where it will be limited reflection from environment. It will be still influence, but not so big because blade causes our problems, not tower. Tower is static object, it is no problem. So measurement reflections requires expensive equipment. Yes, it is true. We made it is about total. How I can tell it? In total price of measurement chain was very approximately 15,000 euros. It is huge money, of course. The majority is for SDRs. Antennas also cost 2,000-3,000 euros, if I remember well. Some amplifiers and so on, wires, but it is not so expensive. But in comparison of price of radar, it is almost nothing because it is much more expensive. All measurements are really time demanding because you need big car, you need to load everything, go to position, unload everything. You need power generator, of course, because there is no electricity, and everything connect, then start raining, okay, everything unconnect and go back to car and so on. So it is time consuming, it is not easy. Also, position of placement of measurement chain is often not available. You will find nice position and there is no road. Believe me, you don't want all this thing, just get it to your shoulder and go go to some field because it is very heavy. Antenna with stand, one antenna with stand about 30 kilograms. Computer is easy, okay, SDR is 1 kilo, it is not problem, but this and power generator, it is also not light, so this is little problem. So and reason for modeling is that we must predict more than extent of verification data set. So output of model is not that, okay, our measurement and modeling is the same. It is just validation. But after this validation, I can say, okay, and now I can use for any scenario what I want. And I know that produced results will be good. It is the biggest advantages of this modeling. So, contribution benefits of model. Cover scenarios that is not yet built. It is good one. When imagine that we had somebody came, some wind turbines developer. I want to build wind turbine there. And you will just run this simulation and told me, this place not, because influence my radar that is 10 kilometers far away. This place, okay, no problem, it is no influence. Of course, it is not 100% fit, but still you have some image, because you can't know it. You will be guessing if not or not. So this will help you. It will help with new radar location. It is just opposite inverse problem. You have wind turbines and you need to place radar, and you can check it. Okay, it is influence, not influence. Good. And new operational configuration, it is mean new wind turbines with new parameters or new radar parameters, updating of radars and so on and so. It can cover also widest extent of operational configuration scenarios, different yaw strategies, different PRF, different waveforms, anything. So you can check almost anything with this simulator or this model. It could cover a wide range of environmental scenarios. It is also important because we have digital elevation model. We know light of sight. So I place position of radar and wind turbines to corresponding places in my model like in reality. So I can check it. Okay, if will be wind turbine on the hill, radar down, what's happen, or mutual position. Also good. It can cover also extremely rare scenarios. What is mean? You have some like bad weather scenario, some really rare big storms, or also something like this. So you can make modeling, you can add validation of this influence of this rare weather, like typhoon, I don't know, something like this. So model generally must be generic and reusable for any parameters. And always your model, you could make more and more extension and add more and more parameters to your model because it's modular. You can add influence of terrain, you can add influence of weather, rain, and so on, fog, and so on, because okay, today morning was really foggy, how it's influenced my radar environment. There is complete structure of our model. Okay, I will stand up because it will be for longer time. There you can see it is affecting parameters. It is input parameters, wind turbine parameters, wind turbine blade parameters, wind turbine blade element, time. What is it? It is PRF, PRI, nacelle orientation, initial angle of first blade. It is random variable, but in model you can change it to any time. Then is factors affecting signal attenuation, antenna radiation pattern. Yeah, I can even change antenna radiation pattern, so I can simulate almost any type of antenna. Good. Free space path loss. It is like energy that is lost due to environment reflection. Good. RCS, radar cross section of wind turbine. It is depends of course on wind turbine. Then, so it is like wind turbine and environment thing. Then we have transmitted signal. Clear, because it is we are on a radar side, transmitting signal. Again, unmodulated pulse, modulated pulse, compressed modulation, coded modulation, what you want. It is just function in MATLAB. Signal okay, transmitted signal, it is go to some from this parameters also, from this parameters is computed Doppler frequency shift for reflection of the wind turbine for each blade element. Also from this wind turbine parameters is computed evolution of range, because if you have radar and blade, you know the rotation, the length will be changed, like range, slant range will be changing. So generally, I will compute range of individual blend element, how it's changing in time. From range, I can compute delay. Good, because what is reflected signal? Transmitted signal that is delayed and attenuated. Good. And not due to movement, it will be Doppler shifted. So from all this, I can compute for individual blade element and from tower and from everything, from any part of wind turbine. I will compute these three things. I will compute also signal attenuation. It is based on range, how far I am away, because you see already radar equation. And of course transmitted signal, I already mentioned. And then you will take it all these things together and make computation of the sum superposition of all reflected signals. Because imagine you have one blade element, and this blade element has own range, own Doppler shift, own attenuation, own delay, but it is delay and range, it is almost the same, it is just pre-computed. And you will compute, so you don't compute one signal, you will compute multiple signals from each reflection, and then if you want total signals, you will just make sum of all signals. Then you make processing of received signals. What is this? It is visualization layer or IQ data or decimating. What do you want? It is just, there is result, this is output, and this is processing. What do you want? If you want make some filtration, something, what do you want? Then you will make saving file and graphical outputs. This could be also this could be also spectrum computation, spectrogram computation, saving file and graphical outputs, just visualization. Model is fully modular, so you can see you could add. There we use only free space path lots. There is no attenuation like polarization. There is no multipath effect. There is not this. You want it? Just put it. Prepare this function and put it. So it is possible make extension more and more, and it will be more and more in details. Of course, it will be computation load will be high and high, but it will be more detailed. So I already explained, and we go to maths. So it is simulator input parameters. Every parameter will be described. So what we have there, I will explain you just few of them, just like example, because you will not remember, because of it is half of Greek alphabet, of course, so it will be hard. X, Y, Z, Cartesian coordinates of your wind turbine. X, Y, Z, Cartesian coordinates of your radar. Rotation speed, frequency of rotation speed, delta L, length of element, psi0, phi0, phi0 initial angle, psi0 mutual angle between PRS and rotation of wind turbine, like not blade but nacelle. Yeah. On PRS we have NROT, rotation of radar antenna. This is PRI, it is just a different name, PRI. This is length of pulse, rotation, it is number of rotation, because spectrogram, how many rotation you want to compute. FR, it is rotation frequency, carrier frequency, sampling frequency. Then is calculation of the conditions and revolution. So it is maximal distance, blind distance, elevation, attenuation, and so on and so on and so on. So this is completely same like this, but this is in variables that we are using in our mathematical model. There is calculation of Doppler frequencies, so you can see Doppler frequency depends on rotation, in each rotation I have number of wind turbines, number of blades. This is length of blade divided dl. This is number of blades element, and it is a replica because we have 3 blades. So it is really complex metrics. Sometimes we are working with 4D or 5D metrics because it depends on many variables. And same you will do it for calculation of time evolution. This for computation of ranges between, and again range depends on in which rotation I am, in which turbine, in which blade, and in which blade position. Signal attenuation, you can see we have simplified model. Signal attenuation is just simplified, that is some attenuation, some constant. If you want some more detailed attenuation, just change this function to another that is in more with reality. Transmitted signal, okay, it is easy. We just develop some transmitted signal, and you can see there is TS, and there should be NTS. It is mean it is sampled. Everything showing in continuous time, but it is, of course, it is discrete. Everything is discrete. In MATLAB is everything discrete. So, but it will be more complicated. So it is just remember. Then from range, I will for each range I calculate each delay, because range and delay, speed of flight, it is mutual together. And from all this calculation, it is like this. I make computation of the sum, and output will be 3D metrics. First dimension will be n-rot. It is mean first rotation, second rotation, third rotation, and so on. How many number of rotation I am simulating. It is fast time and slow time. It is like this one. And then graphical output, it is same like before. So this picture and this picture are the same. Only this is mathematical description of my variables. Of course, you will not remember all of them, but it is not necessary because you will see later in MATLAB and you can check it. Now, I have quiz for you. What is, because our model is algorithm, of course, it is just algorithm, nothing else. Do you know what is essential properties of the algorithm? It is 4 of them. Maybe you have some base programming techniques, so if you can just guess some of them.
Convergence, rate of convergence, and is
Deterministic with convergence, okay, yes.
deterministic, non-deterministic, is it convergent, how fast it is converging, and second thing, there is a region, that the domain of convergence. Yes.
You are quite right. I use little different words, but you are quite right. I have deterministic, finite, resultative, and it is general mass. What does mean? That I can solve entire large group of similar problem for any input parameters. But you say it by little different words, but you say it exactly same. So all these 4 things our algorithm of course fulfill, so we can reproduce this. Now I will describe input parameters. So position, Cartesian, it is night. Blade rotation frequency, RPM, I think that is clear. Length of the blade element, azimuth between gondola axis and PRS, okay. PRS parameter, position of PRS, Cartesian, number of rotation or frequency of rotation, pulse repetition interval, length of pulse, width antenna main lobe, because it is antenna based, it will be wild, it will be narrow. Then time of illumination of wind turbine will be different. Carrier frequency and sampling frequency. Clear probably. Now we go for transmitted signal. How you know, pulse radars can generate, transmit various type of pulse signals. It is just a matter of changing function. And honestly, I think that all of them, majority of them is already programmed. Usually we use own function. Why? Because I have more control on my functions than on like built-in function, because sometimes we use it, they use it some different definition of parameter. It is not mean that it's wrong, but I like control on this, so it is better develop own. It could ranging from classic modulated square waves, unmodulated, or modulated only with sine wave, to more complex signals for pulse compression. Input parameters will be for transmitted signal. Carrier frequency again, sampling frequency, pulse repetition interval or inverse PRF, pulse width and type of modulation or type of compression. Transmitted signal artifacts, it is important thing because the whole model and simulator is quite computerly demanding. So we always looking also for optimization. If I will use something more times, I will compute only once and then use it, because you don't need to recompute. Imagine if you want to model like in previous slide, like on this one, for any sample, I could always generate not the whole signals, but only one sample, and with next cycle another sample and compute it again. Why? I will generate the whole signal in one time and just take it first, second, third, fourth sample and so on and so on. So it is much better, it will be quicker because it not will be under cycle, and usually you do it with matrix operation, because MATLAB is just matrix, it is nothing else. You know what is shortcut of MATLAB? Matrix laboratory. Yeah, exactly. It is just metric, it is nothing else. So, transmitted signal artifact like Rentschler independent on Doppler and long-term amplitude behavior. So, I can develop in one time and then use it. Then, receive signal amplitude. It will be propagation, atmospheric attenuation, free space path loss, optional can be like attenuation in the atmosphere, polarization losses, clear rain, fog. What do you want? So you can add it to this part. Then receive signal amplitude will be for sure affected also by antenna radiation pattern, because it is depends where is my maxima in radiation pattern, what is which side lobes there will be, and so on. So our simulator support only monopulse solution, one antenna for transmitting and receiving. We don't work with bistatic because it is very complicated and you don't need it. We don't need it, so it is just simplification of our model. Then also there is radar cross section, so RCS separation to individual components. And now we don't take the whole wind turbines and compute RCS. We divide it to 3 different parts. Tower, nacelle, blades. It is better for us because tower, nacelle, it is not moving. Almost. Nacelle is slowly moving, dependency on wind direction, but it is relatively so slow with PRI that is static. So MTI filtration, it is just static object. But blades, okay, we take care only about blades. It is high speed. Multipath effect you get at, but it is very hard to model and we don't implement it. It is just our simplified model. It is possible to do it, but it will be very, very complicated, and I have personally feeling that contribution of this will be very low, because with any multipath it is very big attenuation. More multipath, more attenuation. So influence to your model results, there will be some, but not big. Imagine also, where is wind turbine located? In free environment. Okay, there will be some reflection, but not so big one. Definitely, you don't have wind turbines and some skykeeper or something with big reflection surface, if you get my point. So we just decide, no, we don't want to modulate it because we don't need. And it is in receive signal amplitude probably all. Then is range deviation calculation. Range depends on phase and Doppler effect calculated upon range deviation from the reference plane perpendicular to propagation. So it is like this. Of course, this elimination of this artifact is caused by limited arithmetics, because in MATLAB you don't have infinite precision. So we use majorly only single precision, because it is much quicker than use it in double precision. But again, if you want, switch it. It is universal. Is it possible? Then range deviation calculation depends on type of wind turbines, dimension of rotor height, discretization of rotor head blade, of course. Because if I have one blade divided to 10 elements or 100, it will be 100 different ranges or 10 ranges. I know that change will be small because it is just elements one by one, but still it will cause it this, how we saw it already, results from simulation, this spreading in spectra, because it is different. Each element has different speed. Elements that are close to nacelle, they have very, very low speed. End of the tip, very, very high speed. It is Doppler, generally. Then is wind turbine Doppler signature. It is computation of the Doppler depends on wind turbine, again blade elements, elements position, and first time PRI. We are there, Doppler effect sampling. It is first parameter of radar. And what is computational principle? Then we first compute speed of each element, or blade, but blade element, of course, it is independent. Computation of radial speed of each element with respect to PRS, because we need compute first independently on radar what is speed of each element. And based on this speed, it will changing distance and all other things, of course, with respect to PRS, and computation of Doppler frequencies of individual elements. And from the last element, where will be highest speed, we could evaluate if aliasing occur or not occur, because it is clear. The rest, if for the end of blade not occur, the rest is fine, because it will be lower Doppler shift. Then wind turbine time delay signature. So each blade is again has own time. It is clear. If it has different range, then is different time delay, because range and time, it is connected through speed of flight. So computation of time delays of individual blades. Each blade element has unique time delay and frequency shift. This must be clear. And then you make summation. So, and combination with Doppler shift This leads to 2D signature in range and Doppler, and it is result that I show you already from simulation. This free sine wave and all these things. So, can I continue? I think it is. Then it's assembly of model output. So the total received signal is in given resolution cell, in given resolution cell. It is important because it is one resolution cell, one wind turbine, is then sum over all elements and all turbines. And imagine if you have wind turbines, more wind turbines, then what's happened? You need compute in more resolution cell whole the model. And complexity like very quickly growing up. Result of model is reflected signal from wind turbine. I will show you signal structure description. It is in 3D. It is 3D matrix and contains complex IQ data. So important amplitude and phase. It is important. Output are metrics of received signal in each turn. In each turn is different, of course. It is time variable. So we have definite number of rotations. Usually we modulate up to 20, something like this. Why? Why not more? Because it is depends on speed of wind turbines. You definitely won't see this periodicity of end tip of the blades, because when you see periodicity, then it's clear that will be similar. Of course, if you will watch it like 20 minutes and there will be change in wind direction, then amplitude may be little growing up or increasing, decreasing, or changing rotation speed, the periodicity will decrease or increase. It will be like breathing, if you understand me. There will be some changes, but you need to simulate lot of turns to saw it and make definition of these changes, and it is also possible. I will show you later, tomorrow. And imagine, I always told you that radar make detection in individual resolution cell. So I have one row of cells for one resolution, for third one. It is like matrix also. And in one resolution cell is wind turbine. In 5 of them is not wind turbine. In one is, there is. It is almost like sparse matrix. Majority of wind turbine cell will be empty. Do you agree? So it is mean I don't need compute in each resolution cell. But where I need to compute? Only where is located of wind turbine. So of course I do it for the whole rotation, but sometimes I saw it, this wind turbine, and in some azimuth I didn't saw it. So generally, where you don't saw it, don't compute. What will be result? 0. So it is not necessary. It is big speed up. You will see later. All samples, so you will compute all samples of signal in one period, and the total metric signals output is this matrix, but be careful, you also need to put all metadata about your simulation. Or save your Excel file, what you simulate. It is not important, but the metadata please always save. Because, why? Output is signal. From signal you can recognize what you have, which was your setting. It is just output. And when you do it, you will compute spectra or spectrogram, you will see something like this. So, in the next slides, I will show example of output metrics, this IQ data. This is so-called visualization layer. We use it only 2 things, spectrum and spectrogram, because it was for us enough. I don't know if we are missing something, if you have some idea what we could add, what should help us with some analysis. I think that spectrum and spectrogram in this case is enough. But of course you have IQ data. If you want to process with some other visualization, why not? So there is our Doppler shift. There is number of rotation. So you can see I just compute for 6 rotation. This is one sine wave, second, third one. This is flash. You can't do it anything with flash. Flash are flash. It is full of spectrum. And this is like for, it is individual cuts in individual rotation. It is this one. From spectrum, I don't think that you can see something. Yeah. You can see number of blades. 1, 2, 3. 1, 2. Where is 3? This means that blade. This is tower, and blade is rotating, and blade is just in position parallel with. So you don't see it. And for this, so 3 times span 1 rotation, you don't see it. This main lobe. It is clear because always is hidden under tower. I don't know if okay. This second and this is almost this you can see it is always after 120 degree if you will recompute to time, but it is depends on the sampling frequency and all these things. But it normally standard is like this one, all 3 blades are visible and this is 0. So this main lobe is always same, and these 3 they are moving. Unfortunately it is not like there is not so big periodicity that you can see, because it is like recovering, like it is flowing. I don't have free hands, it will be better, of course you will saw it, but it is something like this. But you will saw it. I have a really nice one MATLAB tutorial where you just press arrow and it will be switching, so you will see this movement in spectra. This is our signal structure description. What do you can see it is just from workspace. It is 3D complex double, so it is this 3D matrix IQ data. There is, what do you think that is this one? Tower, exactly. 1, 2, 3, and this is phase. There is rotation index, fast time, and phase magnitude and phase. It is like example first, second, third blade. But from this you can't see almost nothing, if you understand me. It is just we just make visualization with Karel of this, but we never use it like this raw simulated output signal data, because you need to saw in spectrum or in this spectrogram. But output 3D metric is file, so it is IQ data, so it is presented amplitude and phase. And spectrum is of course taken that we compute FFT through all rotation, and it is one spectrum. Through other rotation, again another spectrum, and so on and so on. So nrot is number of rotation of the radar system. It is like 1, 2, 3, 4, 5 in spectrogram, and rep is number of recurrence periods in the area of interest where wind turbines are located. We call it slow time already. And ns is number of signal samples in one repetition period. It is fast time. So slow time, fast time, number of rotation, 3D matrix. And there is picture from MATLAB. So we go for mathematical model. You already saw it, this one, so I suppose that you remember. And there is like depicturing in 3D Cartesian coordinate system. So imagine there is wind turbine and this is your rotation. And there is nothing in the rest. So we don't compute there. Why? There is nothing. So it is like area of interest, if you can. This developed simulator or model support any number of VTs and one PRS placed in any area. But usually in any area it is true, but for us it is like 0.000, if you get my point. You can place it everywhere, but you always compute delay, Doppler shift from this point where is antenna. Okay, I call it that is where is radar located. No, where is like antenna located beam, where is just transmitting this point where is transmitted energy. But I will call it for simplification radar, it is better. So the blue triangle adds the vertical dimension and show the slant range from the radar to the rotating column of the turbine. So we are in azimuth and this is like elevation. And this is results of all computation. Of course, I will show you detailedly how we derive this frequency, but generally it is our model. It is only one equation. It is not looks so complicated, but believe me, it is little complicated to compute this one. So it is output matrix, ID rotation, first, second, and so on, slow time, which PRI, where I am in which PRI, fast time in one PRI samples. This is constant, and I told you we use simplification. Everything is attenuated the same. It is just constant for us. What will change if I will put another attenuation? Change of color, if you get my point in the output. So for me, I want to see what? Behavior. So for me, it's not important if it's, how to say, if it will be real value, if it will be reflection 20 dB or 40 dB. I need see behavior of the evaluation of this one. So this is just constant. You won't change it to attenuation of real radar to real environment. Yes, so compute in more detail, but again will be constant. You won't compute attenuation for individual blade element. I think that is nonsense because it is so small range that will be almost same, but you can. Then not will be constant, but it will be there and it will be changed. And check, there is signal, it is received signal, and received signal depends, it is signal ST. So what is ST? It is transmitted signal originally, but received signal bude transmitted signal minus delay, time delay, exactly. But time delay is depends on ID rotation, ID blade, ID element. One wind turbine, 20 rotation and 3 blades shifted 120 degree, of course. And each blade has sections, these elements. By the way, there we make one more simplification. You can choose only blade element of one size, and each blade has same number of element. It will be so complicated, this condition, if one blade has, I don't know, 5 elements and second 50. It is not necessary. And honestly, the produced outputs will be weird. It will be odd because one blade will be simulated with higher resolution than second one. I think that is not necessary. I think that is clear. And what is this? It is Doppler shift computed. And Doppler shift is computed based on, it is Doppler shift, what is, okay, how you will shift signal in frequency, multiplication by complex exponential, AJ2PF Doppler. But F Doppler again based on number of rotation, number of blade, number of element, and Tm, what is slow time, which PRI. So I know it is one equation, the whole model, ale pretty complicated, it is not so easy. Why we computing, it is how to say, we develop this exact model is relevant for infinite arithmetic accuracy, implementation by range deviation, reduced number of wavelengths modeled. Why we don't use this wavelength modeling, how we already discussed? Because reflection will have random phase, I already show you. And this random phase of reflection will cause us problem if I will do it by different way. So I don't compute the whole range, but only range deviation, and then we can model small range of deviation around a reference distance, around just blades, and not full absolute range, if you get my point, because it is differences, because this avoids tracking millions of wavelengths and makes the phase numerically stable, because it is just difference. And phase, if I will compute just difference phase between elements, then there will be some small difference. But if I will compute always from PRS, whole signal, reflection of Doppler and back, and so on, then if I will use central frequency 10 GHz, lambda is 3 cm, target is at 30 km, I have approximately 1 million wavelengths that I need to compute. You don't want to do it by this one. So it is clear why we do it from range differences. And in case that I make range deviation instead of absolute range, I can constant phase offset ignore, because it is depends only on differences of phases, and it is not for me important. So now we go to slides where is base geometry parameters. So first we will compute this distance. It is to nacelle to rotor. So I know this, I know this, I will compute this. So it is x, y, z position of wind turbine minus x, y, z position of radar squared. It is in 3D. One number, because it is this one. So it is okay. Then we compute azimuth with respect to PRS and elevation. So elevation and azimuth. If we know distance, it will be always constant. Elevation, it will be always constant. Azimuth, it will be always constant. No, it is to center. So it will be constant. It is like when we modeling and blade is not present, like this point only. So these three parameters is constant always. So I can compute only one time, not during each modulation. So it is good example of optimization. So, and which kind of optimization we are doing? So, it is visibility and geometry gating. And this we will do it first time before anything else how is written. Why? If in my resolution cell is not wind turbine, just ignore this place. Just don't take. So what we are doing first time? We have metrics where each cell is one resolution cell. And first time I will check where is wind turbines, where is my radar, what is range of my radar, what is blind zoned my radar, and then told check in which cell is wind turbine visible, and ignore everything else. So you can have complex scene, and then you will see that only in three cells is wind turbines. So we will compute only reflected signal in these 3 cells, and everything else is ignored. So imagine you can have it 1000 cell, and you will compute only in 3. And you not need to check in every cell. It's present, no. Yeah, is present, no. Is present, no. In every run, you will check it in matrix one time, and then just, it is classic binary decision. Is present 1, not present 0. And you just pick up coordinates where is 1. It is good simplification, because if you will do it like hard way for each one, it will be complicated. Then it is first thing, okay, where is present, where is not present, but what does mean that is present? Of course that, how to say, wind turbine is not moving, it is still present in some position, but it is present with respect of my radar, that is rotating antenna. So, okay, you are wind turbines. Present, 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 and nothing. So I can ignore everything. So just in these cases I will, okay, there I need to compute. Rest, ignore. Then we make also fast time range optimization. We are working in range bin space. So we don't waveform simulate sample by sample. We just do it in range bin space. Convolution extremely demanding operation. You probably know it from a maths lesson or some signal processing. If you will have longer, how to say, longer length of signal, like transmitted and received, the convolution is always like shift, multiplication, summation, shift, multiplication, summation. It is just classic convolution. Convolution in time is slow. So and what is opposite operation of convolution in frequency domain? We are in Fourier transform. Convolution in time domain is multiplication of spectra in frequency domain. And multiplication of metrics.
Just like Laplace.
Yeah. Laplace, the transform, Fourier transform. It is, honestly, I always say to my students, all these transform are so similar. Don't have fear from transform. Everything is linear, time invariant, and always it is just transfer to another space. Okay, we can work in time, we can work in frequency, we can work in S-plane if we have Laplace. If I am in discrete time, I have the transform. But it is still same, it is still same. It is just little different formulas. So, convolution we compute by FFT. You need select right exampling sampling rate. Not make so big oversampling. It will be much more samples and takes time this computation. And where is possible, make decimation where is appropriate. Slow time optimization. Separable model. So summation of individual contribution. wind turbine echo is sum of many independent blades, elements contribution. So you can easily make vectorization. Don't think that our model works like for cycle, for each blade, for each element. It will be rotation, time, blade, element. Yeah, it will be maybe 5 or 6 for cycle, like inside 4 cycles. You can't compute. We always make vectorization, so everything is like vector multiplied by matrix, matrix by matrix. We compute everything in one time. And MATLAB is really good in matrix operation and very, very quick. Sorry, I just will. CPI length matched to physics. So pick CPI to cover a few blade pass periods. So, but short enough to limit range work. So it is means not take so long period when it's not necessary. Windowing of FFT. Apply slow time window before Doppler FFT to suppress side lobes. If you will do it in frequency domain, you can't do it simple by simple. You will do it in one time, this windowing. And sparse per bin processing, run Doppler only where 5 stamp power is higher than some threshold or where visible masks say VT is possible, wind turbine is there. If it's not, don't compute Doppler where it's not wind turbine. Multi-turbine or farm, superposing turbines but share pre-computed antenna gains, range delays, and so on and so on. Everything what you can compute one time, compute one time. Don't put 2 cycle. And then it's just standard numerical implementation. Try to make as possible vectorization of the algorithm. It is really speed up. Cache of often used results, pre-results. If you use it something, just cache it and use it just from memory. Single double precision. Single precision will be much quicker. And if you don't need double precision, why do it in double precision? And of course CPU, GPU computation. I must say that this is just future. We don't use it. GPU computation until now. In this model, we use it in some other research, but not now, not in this one, because it was not necessary for us. Okay, we will go lunch.
Let me first check.
Okay, so please check. I will continue and I will do it visibility. Check visibility of wind turbines. So it is classic. What is this? Blind zone. What is this? Ambiguity range. I am outside of my radar. So if will be wind turbine there or wind turbine there, ignore. Just ignore. Don't compute even if it's present, because it is not related to your radar. So max, I think that I can skip this one because it is maximal distance and minimal distance. We already discussed it and we have tutorial. So what is mathematical condition? It is each range bin. You can okay. It is in each range bin, so you can see a grid, and you check it in a range where it's possible or not. You will ignore this. You will ignore this. Orange one, you will ignore area because it is outside of your model. And condition is this: 1, we are in green zone; 0, we are outside of green zone. It is easy. I can't read this one condition, but it is not necessary. I think that principle is more important. In beam visibility, it is interesting because imagine we have this. Okay, first I will show you this one. Do you see this individual range cell? And you can see when you are far, this is longer than there because we are in polar coordinates. And still, this one is one range cell. I put this picture to understand what is range cell. And imagine it is position of one turbine, second turbine. There we have like example 1, 2, 3. So we have like position of radar and it is rotation of my antenna. So you know that this white place I can completely ignore. There is no wind turbine, just ignore it. And there is green area. Why am I interested in this area? Because do you see this one? It is main lobe of my antenna. So I am just on the edge of where I see wind turbine. And by scanning speak, I do it this one. Now I saw one wind turbine, both wind turbine, and so on and so on and so on. And why end of my coverage is there? Because I am just on edge of the last antenna and everything outside is 0. So I will make computation only in this green area. What is outside, I am ignoring because there is nothing. Okay, there will be environment, but I am curious in wind turbine reflection. And this is in 3D. It is similar. I will compute in this, but we ignore all these others. And imagine, so okay, next one. So theoretical range of azimuth, this green area is defined maximum of this minus minimum of this. Of course, it is this difference. You can see it is just two angles. The rest of surrounded area is ignored because there is no wind turbines, and range of azimuth considering this is this one. What is difference between this one and this one? I don't know if it's clear, but this is like inside and this is with beam width. So in beam visibility computation depends on range of azimuth considering antenna and also on antenna pattern. It will be so wild, narrow. Of course, it is depends on this. Everything you can choose in our model. So this rotation angle psi, we could compute it 2p divided 2p ri divided t r rotation. It is time of one rotation, what is 60 divided f rotation, and so on, so on. So number of periods in the area of interest where wind turbine is visible is division of these two values. So this means that in beam matrix visibility depends on range of azimuth, rotation angle of the antenna per second, number of rotation, and antenna RPM and rotation period. Only on this thing. Lunch? Lunch. Okay, please, one more slide. One slide only, and I will finish with in-beam visibility. So, this is matrix of visibility, in-beam visibility. Because visibility, I call it blind area and maximum area, and this is in beam. It is little confusing, it is two visibilities. So it is again mathematical condition, and what is this? It is antenna diagram main lobe definition. We just for simplification use it Gaussian shape. So it is Gauss shape of main antenna lobe. If you want another main lobe, just put another main lobe. It is just function. And check this. What I want to show you. This is azimuth of PRS, how my antenna scanning area, and in some azimuth of PRS, I see first wind turbine. I don't see second and third one due to position. I see 1, 1, 1. And what does mean this if this number is higher and higher? I see only small part of wind turbine, bigger, 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 and then go to down.
Is the pole and
Exactly. When you are exactly direction in a nacelle, you will see maximum and then go out. In this case, my detect overlapping wind turbine 1 and 2, but each wind turbine is in different cell. But I will see, so there is area where I see 2. Then I will see only second, and then I will see second and third. And then so I will compute there, 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 and there. Rest you can ignore. So in this case, I compute only for 1 wind turbine, therefore 2, therefore 1, therefore 2, therefore 1. You can see this big simplification. It is really big simplification. Bunch. Yes. But we are in good time today. Okay. Thank you, and we go. Yes, so before lunch we finished with in-beam visibility, and now we continue with computation of time delay of individual blade elements. So time delay computation is based on the mutual distance, range deviation. So we don't recompute the wall distance again, but just range deviation of individual blades element of individual wind turbines in case that there will be multiple turbines, and all this with respect to radar system. So distance between any blade element formula is present here, and you can see that is dependency on free variable, again index of rotation, index of blades, and index of blades element. So it is these three variables. And how is computed? It is different, it is length of blade elements squared plus distance between wind turbines and radars. It is constant because it is always the same, minus minus two difference element id elements. So this is always changing, of course it is not constant because it depends on elements there is. It is again distance between wind turbines and PRRs multiplied by cosine of angle of rotation of the first blade plus elevation plus 2p id blade divided n blade. So it is speed of rotation, generally I say. So you can see for this I will get again 3D matrix that will includes distance computed to each element for each position, like for each position in rotation. And of course it is the, how to say, it is variable, it is based on angle and elevation because there is two angles plus speed. Usually ID of blades, it is 1, 2, 3 because I think that I will show you some results for 2 blades wind turbines and 5 blades, but we generally use only 3 blades practically. So if you can there I want to describe more in detail angle of rotation of the first blade, where is dependency, because this is angle of rotation of the first blade, but it is also dependent on many variables like always. So you can see the general formula, the final formula, it not look complicated, but each variable depends on other variables, so it start be complicated. And this angle of rotation of the first blade of wind turbines is depends on initialization angle. It is clear. It is start where I am starting. It should be in some position, and I need start from this position, from this position. It is depends on initialized position. Always it is unknown parameter, but how you will see, never mind. Plus 2p is frequency of rotation, blade rotation divided 60 multiplied by time of antenna rotation PRS, because it is two rotation. It is a rotation of blade and a rotation of antenna. So there is two movements together, and index of antenna rotation, and index of antenna rotation is from 0 to n-1, so n rotation, like you see in spectrogram 10, 15, up to 20. I think that we never compute more than 20 because it is not necessary. So initialization angle is random variable, never know when we exact start, and also it is depends when you starting measuring, because it is both combination. As input parameter you can choose any angle, and you will see what will be results that you will choose wrong value instead of your measurement data and simulation, there will be only time shifting. So you could easily compute, simulate it, check it, and okay, I need to shift about 15 degrees and then will be completely matched. So it is like time shift. So, and for this reason we never mind that we don't know it, because I can't evaluate it based on this time shift. If we, after we know this angle, we can combine all this together and compute based on this range. We can compute time delay. It is clear, because when we know range, we know speed of light, then we can compute time delay. And it is what we are interested, time delay and Doppler shift. So time delay is 2 multiplied by blade length divided c. What is this? 2r divided c. Why 2r? 1 trip, reflection, back 2r. So it is classic formula from radar that we already saw it yesterday. So this is range, Doppler shift. In the right corner you can see how we compute Doppler shift. Doppler shift depends on radial speed divided c multiplied by carrier frequency, or 2 VR divided lambda, what is wavelength. It is just for simplification, because Doppler shift of individual blade element is computed from radial speed, and this is for me radial speed. I just use it in my model in MATLAB, this variable, not this VR of course, but this one. So it is just for information. And again, it is radial speed of individual blade element that depend on ID rotation, ID blade, ID element, and Tm, what is our slow time. C, speed of light, carrier frequency. So simulator first computes instantaneous velocity vector of all elements for all rotor speed and geometry. Exactly, it will be again metrics. It is pre-computed for all, because it is better, because it is optimization of computation. And then you project this vector onto line of the side of the radial velocity. So there start be a little complicated. So Doppler shift of individual blade elements, there is angular dependency of course. So there is 2 angles of course. First angle between radar and wind turbine, and then angle between blade shift and radar. So it is 2 angles generally, because you have this one, this one, and this one. So there are 2 angles. It is this one and elevation. For this we use in MATLAB function A10(2), because it is for us quicker, and then of course depends also on elevation. Radial speed general formula is this one, omega r multiplied by cosine ct, and radial speed if will be in vectorized form. So you can see this is vector, vector, and size of vector, where bk it is which blade and which element. So we could make vectorization of all this computation. So, and this is angle of rotation wind turbine elements relative to the vertical position upwards. So after we know angle of rotation that correspond of this one, then this one and this one, we could divide it to, so all these things we need for computation the final angle, that is dependence on ID rotation, ID wind turbine, ID blade, and PRI, it is slow time. It is for individual times for PRIs, because you know always you send pulse, wait back, send pulse, wait back, send pulse, wait back. So it is different pulse, because illumination of wind turbines could be more PRIs, of course, not only one, because the PRIs is relatively short, so it is quick. So it is like quick scanning, you can imagine something like this. So radial speed of individual elements of wind turbines with respect to PRS is based on speed of blade elements, is dependent on element blades. So elements which are near to hub, or to hub, they're moving slowly because they are small circles. In middle will be higher, on the tip will be extremely high speed. Is it clear? It is dependent on this length of the blade, but still be careful. We still compute on different set of elements. We still don't compute the wall distance. We just changing this one small value due to this phase problem if we will use it for the wall length. So radial speeds of individual elements with respect, then I can describe by this formula, where this big this cosine is encodes yaw angle, elevation, rotor phase, and PRS antenna direction. And if you will put all this together and compute, then from, of course, radial speed you can easily compute finally Doppler frequency, and it is what we need for computation of Doppler shift of individual element. So it is just min Fc multiplied by 2 V Doppler speed divided C. So this is final formula that we will put to our signal, like to our, because there is this Doppler shift signal. So what's basically is there? 3D matrix, ID rotation, slow time inside PRM, fast time Doppler processing, attenuation, number of blades from 1 to 3, but it is universal, you can play it with any numbers, and then from 1 to number of elements. So this will be bigger number, of course, it depends how many blade elements you will choose. And this ST without anything, just ST will be transmitted signal with modulation, without modulation, with compression, without compression. It is up to you. Some transmitted signal, it is up to you. That is time delayed, each element and each blade and each wind turbine and so on and so on, and Doppler shifted. So generally this formula is relatively easy if you can check, because of course if it's something moving, how I already answer you, when we have target and we have some transmitted signal, it is reflection. If something move it is time delayed. It is based on length of range, slant range, and it is 2 times slant range, because we signal need travel one way and back. And based on this 2 times range, we have time delay. It is clear. And due to movement, we have Doppler shift. And the Doppler shift is this formula, this F dop and what is inside brackets. And if you will compute this, you will get 3D matrix, and you have one reflected signal based on your input parameter, number of I don't know, number of blades, number of wind turbines, number of blades, number of elements, and so on. So at the end, this is description of complex IQ signal for one wind turbine that can be injected into chosen range azimuth Doppler. So it is in spectrogram, it is on this one. It is, and this correspond to signal from one range cell. Imagine, from one range cell. So if we have, I don't know, 5 wind turbines, and each is in individual range cell, and it has like looks 3 wind turbines, then I need to compute 3 times. If I will have 100 wind turbines, 100 times. And there, for addition, there is for multiple wind turbine, but please, multiple wind turbine means that I have in one range cell multiple wind turbine. If you will have multiple wind turbine and each wind turbine is in one cell, then you will compute by this formula, because it is for one range cell. And range cells are independent, so you don't care. This is completely independent. So okay, you will use it multiple times, depends how many wind turbines, but don't make mistake that is this one. No, this means that I have one range cell and in there is 2 or 3 wind turbines, or 4, 5, it is up to you. So it is different. If I will have in different range cell different number of wind turbines, I will use this one multiple times. And it is end of model of mathematical description of this wind turbines. It is all. So it is all for generation of realistic scenarios, and we will see, I think tomorrow in tutorial 3, about this comparison and how will works together, and you can try it, work with it. So we directly continue with tutorial 2. If you agree, I need to, if you give me.
Sir, like while we are calculating all the elements, like we can calculate the tip and some near elements, so the optimization.
No, you can't, because you will destroy information about Doppler and time delay. This is independent, because imagine this, even this small difference causes small difference in time delay and Doppler, and you can't compute independently, because if you will, you think if you want compute like in vectorization form, or what do you, again please question?
Like it's a blade.
Mm-hmm.
Then like I am telling you, we can calculate for this element, then this element, then this element. Then rest of we will left, because the maximum is speed at its corner.
Yes, I agree. Oh, okay. So, but wait. Oh, I understand you. So you want compute only around this one?
Yes, yes.
I don't recommend you, because what you will see in spectrum, you will see only this small part, but you don't know what is happened there. You don't will see complete spectrum, and for you it will be also hard to make. You will need to make extraction from only some spectral lines, if you some part of spectra. It will be very complicated conditions, and then you will see just this one, and this one, and there will be empty. So no, because then this rest, it is this low, not maximal frequency, but this lower frequency. So no, you will not see the whole picture of the scene. No. I get your point, but imagine you will see only like small part, like really narrow part of spectrogram, and without, and what will be there? what will be inside? You even don't see reflection from tower. So no, I can't recommend you, because if you will see only this, in some cases that will be higher noise, and when it's really hard to see this sine wave, then you can't recognize that this sine wave. I can't recommend you. No, just compute the whole one, because I know, I get your point. You won't compute just DSC and rest, I don't care, because there is not big influence. It is hard because sometimes you can see there is also some maxima, something like this. So no, you need to see the whole picture, what is inside. And how you want to comparison with real measurement? It not will be possible. But a good point. I get your point now. Yeah, with optimization, but I can't recommend you this one.
I have one more question. Let's suppose it's a WT1 and it's a WT2, and from your side, like the radar is in front of you.
Yeah.
Then we are collecting the data. How we will differentiate these WT1 and WT data? How we will differentiate, like
you mean that you have two wind turbines just each other? It is easy. I told you one answer. The rotation, how to say, rotation of each wind turbine is not synchronized.
Yes, sir.
So it is rotation of blades. First one and second one will be different. So you will see 6 blades.
Yes, sir.
Generally.
Yes.
Yes. It will be, but again we are back. Each wind turbine for really high probability will be in individual cell. You don't care. You are computing for one cell, second cell.
Yes.
So if will be in different cell, you never mind, because you compute for first cell and second cell. Even if it's like say like this and this, I will compute this one and then this one, because it is different cell. If will be close and it will be one cell, then it's multipath, and it is the last formula that I show you. It is depends on position, but it will compute. Okay, if will be like this, and okay, just hypothetical situation. I have 2 in one cell with same rotation speed. You can't recognize because you will see only one. But if they will have different,
yes.
then you will see like one blade with one wind turbine with 6 blades. You are
Yes,
right.
sir. Yes.
You are right.
Like 6 sine wave we will show in the spectrogram.
Exactly. But it will be so rare because how I told you, we make a lot of real analysis, and always happen that wind turbine was in different cells. You are right. If we have some radar that will be for long distance radar, like in 100 kilometers, 150 kilometers, and you will look on wind farm, offshore, coast, something like this, then could be 20 of wind turbines in one resolution cell. You are right. So there you will have problem, and probably our mitigation techniques will fail. But for this big wind farm and all these things, you definitely need to use some different solution, because it is not possible modulate. And other thing, if you are like in longer and longer distance, there will be bigger and bigger attenuation. So reflection from wind turbine will be lower and lower because you are in longer distance. So you are right, there will be hard to predict, there will be a lot of problems, probably will fail mitigation algorithm, but I don't think, how you already can see through math algorithm and through everything, it is so complicated that don't expect that you will design solution that will work always for any cases. It is just not possible in this case.
Yes.
But you are right.
Thanks.
Thank you for question. It was interesting. So I will send you all of you tutorial 2. Give me 2 minutes. I will just run my Outlook and send you in minutes tutorial 2. I hope that is not so big. Just give me a second, I am sending to you. No, I just disconnect, it is okay, don't worry. Okay, email sended, you should receive tutorial 2. On tutorial 2, I will cooperate with Dr. Ashwini that is present there, so if you have any question also you can ask him. This tutorial we will continue with our analysis how wind power plants interact with the radar system. So based on our lecture, we will check first blind zone, maximal zone, and we will play with these parameters. So the first tutorial will be related to pulse radar parameters, to blind range and ambiguous range of wind turbine visibility. Then we interpret the microdoppler signature of wind turbine in time domain, phase and Doppler spectrum. Then we can use interactive MATLAB tool to see how rotor speed and azimuth effect receive signal, and also understand how the antenna beam pattern and blind zone determine in-beam visibility of wind turbines. And in like advanced task will be assess how rotor speed, blade length, yaw, blade count and initial angle influence wind turbine radar echoes and microdoppler spectra. So visibility of wind turbines is clear. We need define wind turbine blind zone and unambiguous range condition. So all wind turbine that is in orange area will be just ignored. because it is not in instrumental range of my radar. There will be visibility of wind turbine by impulse range, so please open your MATLAB. Okay, it is still starting. Okay. So there is example how look your pulse train, and on the upper picture you can see the red part is transmission part plus recovery part. Green one is receive window, now is dead zone set to 0. Then is, and there is one period, second, third, 4, 5, 6, 7, and so on and so on. This upper picture just show you detail of first two periods, but there is whole picture of pulse train. So you can see that for this setting that was carrier frequency 5 gigahertz, number of periods, so it is definition of pulse train, the whole simulation time, definition of time vector, and now I am missing where is that? There. Okay, I missed this parameter. Speed of light, length of pulse, and length of PRI. And recovery time, I was set tau divided full. You can, if you don't want to use it, you can use it just 0 or something like this. So, based on these parameters is automatically computed time of blind zone, length of blind zone, and ambiguity range. So you can see that blind zone is 2250 meters, so it is mean that on this frequency first 2.5 kilometers you can ignore. Or you need to change PRI. If will be wind turbines located closer in the blind zone, you need change parameter to fulfill all parameters for getting reflection. Ambiguity range is about 15 kilometers, duty cycle 10%, number of pulse in CPI is 10. So you can please change parameters like number of periods, you can change carrier frequency and rerun, and if I will change this thing, you can see that number of period is this. Carrier frequency of course didn't influence blind speed and ambiguity range. If we make pulse shorter, 1 microsecond. Of course, there is the blue line and red one. Then you can see I have longer listening time, so ambiguity blind speed now is not 2.5 kilometer but only 200 meter. Ambiguity is this one. If I will change back to this one and change PRI, I don't know, to 50, so it is mean now will be duty cycle 50%, 20%, sorry. We get ambiguity range only 7.5 kilometers, duty cycle 20%, 15 periods on CPI, blind range is still same. So you can easily check if, imagine if you, how to say, if you first looking to map and you plan some measurement place, you could put your data and check if you are in blind zone, not blind zone, just through calculation. This visualization is not so important because it is clear that you are transmitting pulses, but what is important is this, these values that is computed. So, it was this example. Yeah, it is what I already described, but in by words. There you have explanation. Please try. I have some suggested exercise and answer me. If you change tau from 10 microseconds to 30 microseconds, what's happened to blind zone? Just let me know. If you will change tau from 10 microseconds to 30 microseconds, let me know what's happened. Yeah, just answer.
Blind zone means increase.
Yeah, and from which value to which value?
3 times. 6, 7, 5, 0.
Yes, okay. And if you double PRI? If you double PRI, so it will be doubled, then it's clear that ambiguity range will be
3 and 4 times 0.
it will be 2 times higher from previous case, because of course, why? Because you are listening longer time, so there the pulse have longer time to get there and go back exactly. So generally shorter tau, smaller blind zone, and you can detect closer targets. This combination of PRI, tau and so on, of course depends on the kind of radar systems, because you can have it long range system, and for long range system, like example, if you have some primary radar system for 400, 500 kilometers, the blind zone will be relatively high. Why? Because it is long range radar. You are looking to long range radar system, and of course radar can't work like from very short distance to very long distance. It is always some trade-off. As I have long range system, it is for detection of what? It is first warning detection. Be careful, something is 500 kilometers far away. Then we can call it middle range radars. It will be up to, I don't know, 100, 150 kilometers. They will have better resolution. Why? Because the range cell is with distance is always bigger in size. So it is clear that resolution is relatively lower because bigger range cell. So don't expect that with one radar you cover everything. No. Usually if you look to some military books or something like this, there is always different layers of protection. First warning, okay, completely first is so-called OTH radar. It is over the horizon. They use it reflectivity from atmosphere to detect target even after horizon. It is like this 500 kilometers. And then you have some middle range. They will have up to, I don't know, 100, 150 kilometers, and then have it short range and very short range. And it is clear that like short range up to, example, 30 kilometers, 20 kilometers, they will have good resolution, and they are for detection of not usually fighters or something like this, because if fighter will be 30 kilometers far away from you and press button and hit some, I don't know, missile to you, forget, you don't have chance to react, because it is short distance and missile is so quick that you will be dead, if you understand me. So for this short range or very short range radar, it is for detection small and small targets, like this very short range up to 30, 20 kilometers, or some radars are even up to 5 kilometers. It is for detection, like example for UAV or something like this. But I think that UAV, if I remember well, and what I saw it, they can be detected up to 20, 25 kilometers. But not mean that all of them. If will be UAV like 10 centimeters, really small one like child toy, it will be much shorter distance than if you have UAV with quadrocopter like 2 meters or something, because it is always about RCS. But you remember, RCS, probability of detection and probability of false detection. So it is combination of all parameters. So by setting of these parameters, you balance, minimize blind zone while keeping decided unambiguous range. So you always need to make these differences. Next will be wind turbine microdoppler, matched filter, amplitude phase in range, and spectrum. Please open wind turbine microdoppler application. And you will see this application. There is matched filter output, and what is mean this one? That we have some target in range bin 55 or 53 or what is it? Can you see it? So it is mean in this range bin is target. If will be second target, it will be looks like example there, 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 and so on and so on and so on. And there you can see slow time, and what is this? It is our spectrum. So if you will check this scenario, is it clear that I just simulate this is tower, one blade, second blade, third blade. It is for some setting. PRF is 5000 Hz, so I have the whole range from -2.5 kilohertz up to 2.5 kilohertz in Doppler. And what is this upper right picture, it is amplitude in turbines of range wind. So you can see there is slow time and there is amplitude in dB, and this is phase. And check this phase. It is from movement of blades. So we have multiple movement. We have movement of antenna. We detect target in fast time about 65 microseconds. So you could recompute to range, how far is it. And do you see this one, how is relatively, it is not periodic, but so call it quasi-periodic because it is not same. This is microdoppler. Do you remember I told you when you have movement you have Doppler shift, so it is just carrier frequency is shifted to another amount and we can recognize speed of this target. And if target have blades, okay, I know that not exist yeah, it is exists UAV with 3 blades. You will see movement of these blades also, and we call it this microdoppler. It is this one. You can see it is slightly periodicity. It is not complete period, but it is slightly. Why? Because reflection is of course how is rotation and his movement in environment. Then you get always little different reflectivity. And this is microdoppler. So, and from this microdoppler, it is very often, and I think that is future in a radar system you will use later for classification of target, which type of target. Because if you have like quadrocopter, 4 blades, it will some different shape. Even you can recognize which developer, which type of quadrocopter and so on. Why? Because you will know what is shape of blade, how it looks like. Of course, if you want to make if you want to make classifier based on microdoppler, you need to have all measurement of this. What do you want to recognize? Because you can't recognize if you don't know this kind of UAV, or you need to train this classification method if you want to use ML or something like this. So it not will be easy task. So for my opinion, I think that is future, but we still don't reach the future. But exists few companies that even can recognize. It is a little similar. It is, I think, some England company, I can't remember now name, and they are specialists for recognition of birds, for birds detection. And they have some classification of birds that even from movement of wings, if you get my point, and not only this of wings, but also style of flying, because every bird has different movement. They can recognize what is which bird. Of course, it is usually very short range, few kilometers, because they are small one, of course. So and the reflectivity of body is not so big. It is not metal or something. But it is exists. But I can't now. Sorry, remember what is name of company. No, I can't remember. So now we move to this one. How you can see in this application, it is for simulation of microdoppler demo. There is definite a lot of scenario that we pass one by one, and there is also a lot of different parameters. So again, we start with carrier frequency. It is clear. Tau, so it is mean length of pulse. PRI, you know already what is it. Number of pulses, so 100 PRI pulses is 1 coherent processor interval, CPI. R0 is distance of target, blade length, target, okay, I mean tower, blade length, number of blades, and speed of rotation, and signal to noise ratio. In advanced parameters, you can change carrier frequency. It will be related how will be spectrum visualized. Kappa, it is shape factor, just ignore it. Alpha hub and alpha tip, it is mean reflectivity, amplitude reflectivity of tower or tip. It is just simulation. So if this mean that hub tower has stronger reflection than blades reflection, so you can just tweak it how you want. And there is rotor azimuth, and every these parameters you can change and just recompute and see visualization. So this for you know what is already displayed there. So it is where is my target in each reach band, how looks amplitude in a reach band from this my reflection, how looks phase, and how looks spectrum. It is all. And there also is pre-computed some base information. So PRF, okay, it is computed from PRI, of course. Nyquist frequency, what is mean maximum Doppler shift, and then aliasing occur. And there is also compute tip of blade, so end of the speed of the blade at the end. It is depends also of course on the blade length and maximal Doppler, but it is half of this one approximately. So if I will choose 250, you can see that Doppler tip is higher. If I will choose to 100, blade tip 157, and maximum is I think about, okay, it is under 150. By the way, I sometimes put some limitation of parameters because due to if you will put some higher, then it will be hard to, how to say, visualize it, and it will be some artifact, so it is just a demo. But this limit is chosen that should cover almost the whole entire range of our used things. So you can see it how it's changing, because there is some also noise. So when you update, always is recomputed with another noise. So it is depend how well looks like. And now we'll be go one by one scenario. So if we will go to nominal, we already see it. There is tower, first blade, second blade, third blade, or first blade, second, third. I can't recognize which is, it is not important. Always when I simulate it, I tell, okay, one is first and the rest is just 120% shifted, but in reality, it is not important which is first, which is second, because there is no meaning about it. Sorry. Second is long CPI. So if we will make long CPI, so you can see that I make 512 PRI in one CPI. What's happened? Spectrum is in much bigger. Spectrum is in much bigger detail. It is like better draw it. There is clearly visible on zero Doppler frequency the hub. And in range bands again you can see target, there is amplitude, and there is Doppler shift. You could change to 100, try put some few details and you will see what happens. It is the best one if you can play. Okay, the lowest is 50. Oh, no, 50. Okay, sorry, some problem. Oh, maybe. Yes, 50 is the lowest number that didn't work because there I have some problem. Of course, I didn't test the whole number, so I apologize if some for combinations, strength combination of parameters will not work, but should we work. So, if I will increase number to 112, like example, then you can clearly see, okay, 150. So in the time domain behavior in the turbine range band is similar, but slow time spectrum becomes much sharper. And exactly, why sharper? More PRI, so more data. If you will put like metrics, slow time metrics, I have 512 samples in FFT. If I have PRI 200, or like number of pulses 200, I have only 200 samples in FFT. Now I have 500, so it is clear that will be sharpened because it is more samples in same range, because still is 2500 to each side of Doppler spectrum. So we can move to Heisenberg. With Heisenberg you can easily see how we have like the rest of clutter where its noise is very low. The visibility of the main lobes of these turbines is clearly visible around problem. And now please try just put lower and lower and lower, and you will see that the differences between this level, like this level and this level, will decreasing and just disappear. And it is mean that noise win. Just try it also, because I think that is best. You can see how goes noise up, 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 up. Because on tutorial I really like if you play with my softwares, because it is much better. I know this software, but it is much useful if you can do it. And I will always make commentary. Okay, you can see mine's 10. Still 10 dB higher, but only 10 dB. We was about 40, 50, something like this dB. 20. Okay. And we are lost. Noise win. So, then we go to, sorry, I always lost. Hub dominated. What this mean? There is always some suitable setting. You can see that for each scenario, sometimes I change more parameters. It is just due to visibility, because it is like visualization. I want to show what you can choose and what will be impact. Of course, in reality, in radar, some parameters will be almost constant for some regime, but this is like teaching purpose, so it is. I honestly must find for all this scenario always optimal setting parameter to what I want to show. So like this one. And now we check it slow time, and if you go to advanced, then alpha hub is 1. So you can see reflection from hub is very, very strong in comparison of alpha tip. If I will go to lower, even, you can see but it will be probably very low. Yeah, you can see now it is just reflection of how to say, of tower, not reflection of blades. But what I can simulate by this, different kind of materials. If you get my point, I know for me it's constant, some ratio, number of ratio like amplitude. But you could easily simulate if you know some reflectivity, like parameter, you could adopt this application and based on reflectivity of real some material, you can check, okay, will this blade so many visible or not will be so visible. Imagine that now when I just go with this one low, I make simulation of RAM materials, these expensive materials on wind turbines, because reflectivity is extremely low. It is just this example. You can imagine that, and of course if even tower will be very low reflectivity because I will use this radar absorbing materials, so I will put 0 point, I don't know, 2, something different. I will recompute. Okay, it is too low. Sorry, we are back in 20 dB. Okay, and now you can't see anything because it will be just noise. But it is not mean that it's wrong. Okay, wind turbine, never mind. So you can even change this. So try plate for 1 minute, 2 minutes with this, and we will continue. I will be prepared with kappa. Kappa is, how to say, it is line of sight projection factor. That physically means the turbine is observed more from side, so only smart fraction of the blade motion project into line of sight. So you will see only part of movement. So if I will see only small part of movement, if I can, then it's clear that Doppler will be lower and lower and lower, and this all reflection of free blades will be like narrow. And if I will make some extreme, it will be 0 and it will be just tower, because, but it is nonsense of course, because it will be, it is mean that should be, okay, we have this, there is some radar, there is tower, and this is radar, and it will be like this, but this will be extremely thin, if you get my point. So okay, it will be extremely high speed or high speed, but it will be so thin that reflectivity of energy will be low, like example this. So again, play with this number, try to change maybe to 0.1. Yeah, you can see this. It is not, it kappa line of sight is like propagation factor. Okay. Oh, I forgot blade dominated, but blade dominated, it is mean that hub will have low reflection and blades will be high reflection. So even I can do it this one, and of course it is same, it is just about ratio of amplitude. But it is not bad, you can change a lot of things. Imagine, there we can change, I don't know how far away from us is wind turbine. So we just 2 kilometers. Okay, you can see 2 kilometers, 15 kilometers, and so on. This is about rotation speed. So if we have fast rotation, no alias, so it is mean it is classic, 3 blades, everything is perfect. You can see Perf is 500, Nyquist 250, tip 100, ED max is 2010, and we have maximum 2000, maybe we have maximum 2500, and our maximum Doppler speed of blade is 2010. So we are under aliasing theorem or sampling theorem, and now Nyquist is 2500, but F max due to really high rotation speed is this one, and it is mean that still you will see 3 blades, but it is not correct position, because imagine, like example, this should be there, but it is aliased there, or this should be there, but it is aliased there, and it is dangerous. Why? How you want to recognize from real one? You can, because aliasing occur. You don't know. It is same like if you make sampling of your voice, and it will be aliasing because you use, I don't know, only 10 kilohertz of your sampling rate, but your highest frequency in your voice will be 20, so will be really undersampled. What's happened? It not will sound like your voice, it will be something strange, or okay, maybe you can recognize voice, but will be, it not will be same tone, something, but how you can know if you don't see original that is wrong? Because you made bad sampling. It is same, it is exactly same. And the worst case is that if it's aliasing occur, there is no way back, because you don't know how looks original. From this I don't know where was original. I even can't guess. I just don't know. Okay, we simulate also L-band and X-band radar. So L-band, it is for 256 pulses length of CPI, and 3 blades. You can see, because the wavelength is longer, the same mechanical tip speed produce lower Doppler frequencies. So you can see, because we have lower frequency, we have higher wavelength, and it is mean that previously was about 2500. Now we have only for maximal speed, for same maximal speed, we have only Doppler shift 500. It is due to that I have lower carrier frequency. So it is mean lower and lower carrier frequency, lower and lower resolution in Doppler speed. But it is exactly same what I show you in lecture 2 when we have this graph, when we have dependency of carrier frequency. This line, if you remember, it was parallel line, exactly. It was the same. It is just practical. And just run X-band. And you can see the same setting, completely same setting, just different carrier frequency, produce not 500 Hz but 4000 Hz. So it is just about wavelength. So, good, are you satisfied with this example? Can we continue, or you have any question and you want ask me something? If not, we will close this application and please open the next one, and it will be wind turbine micro Doppler scenario apps. No, interactive. Oh, no. Okay. Just give me a second. I have so multiple applications that I am not sure. Yes, this one. Ah, yeah. Good. Open this application. It is better if you will open in your laptop. And now you can use arrows. If you go left, right, I will changing azimuth. So what does mean? How? Okay, if it's this wind turbine, it is same like if I rotating around wind turbine. So it is different azimuth. So I see, and wind turbine is like in this. I am going around wind turbine. So it is mean that I see blades in different positions. So it is changing, and there is perfectly. Just run, please look at this. You see, it is what I want to try. It is movement of my blades. And what is only one stability? This one.
That is the
Tower, of course, static. Yeah. But I like this example because exactly and you want to predict this one. So you can see it is really hard to predict. And now if you go with arrows to up or down, you will changing rotation speed. Look, if I will changing rotation speed to almost 0, what I see? Tower. It is not only tower, it is also blades. But why I don't see blades? Because they are not moving. Because frequency is 0.01, so I can't set 0. Why? Because MATLAB will have problem with some error, because there will be some division with 0, if you understand me. But it is good example. But even tower will have some Doppler shift. Do you know why? It is movement, just due to this movement of blade. Exactly. It is mean even woods, even everything is moving, because if you have wind and just trees do it this one, small movement, it is enough. It will be some micro Doppler. So it is mean nothing is static. Okay, table is static. It will be really 0 if you get my point. But outside, everything is little moving or jittering or shifting, something like this. So exactly. And now we are on 0. And again, there is amplitude and phase, but it not tell you much more information. Of course, I have it for spectrum, but it is not bad to saw it. So please, plate, left, right, function. Okay, maybe you can set some rotation speed, not 0, and try find azimuth when two blades will be, how to say, in same position, so you don't see 3 blades but 2 blades. And you can try to find multiple position. I already found one like this. Of course, it is depends on step. You can see now is this with tower. So it is mean that I have rotation and it is just exactly, yeah. So after 120 degree, second one will be same, after 120 degree, last one will be in same, and it is still repetition. Look, now this one moving close, 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 okay, and I am just opposite to tower. And the left one now goes to tower, and so on and so. So you can play it. And rotation speed, and we can, and you can change also again. Signal to noise ratio, you can see again up and so on. So there is presence of maximum microdoppler, okay, and I will show you aliasing. There is aliasing, so it is mean, I forgot almost, there is always description what should you see. So you can just run it and read it and you will know it. And there aliasing occur, and also I don't know if you realize there is changing of parameters. So azimuth, left, right, arrows, rotation, up, down, it is clear. And there always you see what is rotation speed of wind turbines, what is Maxwell Doppler, and if you have bigger screen you will see in Nyquist, because honestly there is a lot of parameters and on my screen it's not possible to show it. But if you have classic display, big one, you can see every parameters. I am sorry about it because I am testing all application on my big screen and everything's work, and then I just came to IIT and just okay, I will testing, and now I just discovered that half of parameters I can't see, so I quickly adopted, but somewhere I don't finish it. But on big screen will works nicely. Okay, we go to in beam visibility. If I will switch, it is this one. So in beam visibility, I have beam, I have this is my green area, is location where I search it wind turbine. So now that it is first beam where I just touching off first tip of blade, something like this, just on the edge. Then I move, and will do it something like this. And of course, in sometimes I saw 1, 2, 2, 1, 1, 1, and so on and so. It is for this optimization, how I already told you. And there is this 3D projection to individual range cell. So open D, beam detection in circle. By the way, when I share you tutorial, I don't know if you are realized, but always there you can see what is related script or a related application, so you don't need found it. It is always there, this information. Okay, by the way, it is just for visualization. This is wind turbines, but when you run it, it will be always position of wind turbines is random. In every run, it will be in different position. Of course, if you want, you can edit my application and place to exact position where you want, but I use it for visualization. And this small circle, it is blind zoned. This is bore side, it is mean where is maximum of your beam. Green will be which one is detected, red one which is not detected, and this is detection boundary. It is like maximum distance where I can detect targets like this one, and this is just area. And now just left right. Look, okay, I see. One. Don't see. You like simulate radar rotation antenna. Of course, you can adopt your values to and put some map under next layer and could correspond to reality. But for me, it's just now visualization. But you can edit my app and improve and send to me back. Okay, there is also parameters in this application, because now this looks that you can't choose it anything, but check there. There you have these things. This is definition of beam width. So if you will increase, it not will be narrow, it will be higher. This is maximum bore side, so it is range. How long is this? Where I can see it is scene radius. Okay, we not care so much. It is blind speed. It is not computed from radar parameters. It is just, you need to compute with first application and put just number there, because it is, you know, I don't want interconnect everything together because it start be confusing. So we will make narrow but longer. No, it is too much. 40, it will cause problem because maximum circle is 40. Yeah, I will be outside. Okay, it is always one. So sorry, I will make. We will go to 25. It is not good antenna. Because of course you want a really narrow one because it is better. So it is just for example that work for multiple wind turbine. It is really fat antenna. Oh, sorry, you don't see it. I saw it in my screen. Okay, 3 of them. Maybe it will be useful when I now think about it, if I will put also range bands resolution, then you can see if it's in one or different resolution cell. Okay, it is as a hint for next time that I will improve application, because if you will see this range bands, then it is clear, even it will be clear if it's multipath effect or not multipath effect, if it will be in one range band or not. But now, sorry, I just figure out now. And again, there you have parameters, changing parameters, so you can easily clear. So I will close and we go to tutorial 2. This one. Okay. In majority of how you could see in majority of tutorial 2, like, sorry, this is my Czech name, I just forget, but never mind, you will saw it with this tutorial, so you can follow. Usually, in each directory, you will see name and same name with 2. Where will be 2? There is GUI, graphic user interface. Where is not, it is just to command window or something like this. Honestly, I make conversion to GUI version during weekend, so usually I use only command. So if you will find any problem, just let me know. I will correct it because it is not full tested. I just doing during weekend on IIT. No, it is not GUI, it is, I will explain you later. All this tutorial that I will show you, it is relatively time consuming because it is already computation of the whole spectra from our model. So sorry, I can't speed up. Okay, I can present you just results, but for you is better if you can change parameters and just run it and present own results. But I can't do it now because we just need to wait to finish computation. This is the longest one. It is, you can see 20 scenarios, 20 rotations. So it is mean I will changing rotation speed of wind turbines, and each how to say, each results will be for one rotation. So first rotation, second. No, it is not me. Good. So check, there you have 20 figures and each is for one rotation. So first rotation, 2 RPM, speed 3 RPM, 4 RPM, 5, 6, 7, 8, 9. Somebody can tell you, well, but there is not sine wave. Everywhere is sine wave. But what I told you, you need to have, in some cases, big imagination. Why sometimes is hard to see? It is due to combination of rotation speed of your antenna and rotation speed of blades. But always is there sine waves, always. But sometimes it's hard. Look, for this, for 7 RPM, it is completely clear. Everybody saw free sine wave. For 6, it is little. Oh, sorry. You need to tell me that I have on my screen and not your, your screen. Sorry. So, 1 RPM. It is clear that there is almost not visible sine wave. Rotation per minute is only 1. It is so slow rotation of blades that it's almost static. Static will be, of course, just pure 0. But you can see that it's just around 0, so there is not any much to see. This you will filter by MTI filter. 2, 3, okay, for 3, and why there is visible and for 2 not? Because for 2 is combination of both speed, not so nicely visible ratio of my radar and of wind turbine. But it is not mean that mitigation algorithm don't see it. It is just visualization for us. 4, okay. it is there. But you need little experience, but we watch it many times on this. But for honestly, for some combination like this one, it is really hard because you know that will be passed through somebody. But combination, combination could be so bad that you always skip some parts that looks like that is like this one, like zip or something, but still always is there, this free frequencies. Okay, and for 7 you can see without problem. 8, 9, 10, okay. Explain me this one, this result. It is strange. What do you think? Why I don't see anything? There, okay, we agree, all of us, there is not sine wave. There is no doubt. Why? Think about speed of turbines and radar, nothing else.
Both are same. That is why it is showing. Because in other cases,
Both are same, so it is mean radar always watch in specific time and watch in specific time, and the specific time due to same speed is same reflection. So you can see constant. Exactly, both are same. Oh, congratulations. No, but it's really good because a lot of people think different theories, but it is first time who answer me right. So perfect. And it is for 20 rotations, so there will be again some repetition. You can see, okay, this is strange. But it is 90 RPM. It is okay. It is too much. It is nonsense because maximum could be about 12, but only for blades up to 40-50 meters. For this 160 meters blades, it is nominal speed maximum about 6-7 because it is so long blade that the speed can't be so bigger one. So okay, you can simulate anything, but the rest of results from 14 up to 20, okay, we simulated, but it is relatively far from reality, so we don't need in account. And it is not all. I need to show you this one, tutorial 2, and I want to show you this one. Every how to say, every this simulation, there is some variable, and check. It is just simple Excel file, how you can see it, nothing complicated. What is X, Y, Z? Position of my wind turbine. X, Y, Z, position of radar. Number of blades. Number of rotation. Length of blade. Different elements are different, so about 45 meter, 1 meter. You can put any number. Initial angle, antenna width, azimuth, and sorry?
speed of radar.
Yeah, exactly. So you can, if you want 1000, just put 1 to 1000. He will read it always the whole column, everywhere. So even if you will put like, okay, this is static, it is only one number. Please never put 2 numbers because he will be crazy, because it will be some problem, some error, because I don't make controlling of variables, because you know, you can put 3 blades, 5 blades, 2 blades, what do you want? And if you put like 3, 4, 5, 6, then he will compute all computations. So 3 up to 1 to 20, 4 up to 1 to 20, 5 up to 1 to 20, all combination. Be careful. If you will put, okay, probably you will stay free because it is nonsense. length of blades, you can test multiple different length of blades, but not put like 20, 30, 40, because the number of combination will rapidly increase, especially if you like change, I don't know, speed of radar, or you can change azimuth. Azimuth is a really good one, because you don't need compute in one azimuth, you will compute in whole azimuth range that is decided. So I think that is very easy. We want to make simplified, because it is not any commercial application, it is for us. So of course you need to know what to put, but this, I think, that is clear. Okay, so we will go to rotation speed. And you can see there is always, how to say, rotation speed, but it is completely same, only I changing Excel, because it is still same. Oh, 24. Okay, we will need to wait. Okay, this is the longest one. In the meantime, you could check how looks this complete script, where is transmitted signal, load data from file, scenario vectors, and check length of blade, length of speed, and so on. So he count everything, and this is just individual, how to say, okay, now it didn't work because computer, it is individual function, so it is this simulator. Where is result? So it is changing azimuth. Can you see it is changing azimuth? It is means that sometimes I have constant, now I will have constant, now is increasing amplitude, and so on and so on and so on, or back. So exactly what I already described. And now we will make changes of number of, just for fun, number of blades, but it is just cosmetic for showing that values are, but it is not necessary. It is up to 5. So for one blade, 2, 3, 4, 5. But of course 3 is mandatory for us. And this one, there is only really one sine wave, but speed it very, very quickly. It is hard to see for some cases. For 2 blades, I even can't see. I know that is right, that is correct. For 4, it is visible. For 5, also correct. But last one, what I want to show you is initialization. Because I told you that initialization angle is only shifting in time. Don't worry, still computing. Or I can show you before. There you have initialization angle. If you can see, there is 0, there is 30, 60, 90, and it is always that you take this and make like shifting. So in case that you make a measurement and you don't know initialization, never mind. Just try to find exact value when will be covered with the same shift. And it is what exactly I say. Okay, it is now no random parameter. We can find it. Sometimes take some time, of course, but you can find it. And there you see for all from 0 to up to 360. So this and this is science, of course. But it is like shifting in this way. And what is up goes down. So it is just really shifting. Like sine waves shift. Like phase in sine signal. Okay, I think that it is all, and it is just exactly 2 hours. Or almost 2 hours. Okay. If you have any question, please try all MATLABs. If you have any question, let me know. I already sent you tutorial 2. And about tutorial 3, there is a lot of HQT data, map data, and so on. And I just checked it, that size of this tutorial 3 is about 900 megabits. Where to upload and where to share. Do you have any spaces? Can I share somewhere? Can I upload somewhere? Because it will be nice if you will have it, because there is also measured data, simulated data. So I would like to share with you, but I don't know. But I have your email address. So by the way, do you know WeTransfer? I will check it if it's possible to so many participants. I have problem that I know a lot of sharing services, but usually it is only too few people, and there is certified.
The size is what?
About 1 gigabit.
It's okay, you just share me. I will share from.
Okay, so today I will upload the whole tutorial free, and you will share it with participants. Perfect, thank you very much, because I can't upload it anywhere. So tomorrow we will play with this thing. Tomorrow tutorial 3 will be about measurement, comparison measurement, and so on. So we will play with this. Today I think that we finish all these mathematics things, and from tomorrow will be more about planning. We will play with maps, we will play with this panorama, we will play this OpenStreetMap and all these things. I hope that everything will works, because this online service is sometimes a little tricky. Okay, thank you very much for your attention and see you tomorrow at 10. I will be ready. Oh, if you want to play with map source, you need to install QGIS. Please just go to download page and download. I will send you email where to download, and just download QGIS and install. It is 1.2 gigabit, so something like this. Just download and install, please, if you can.